virtual conference on expanding frontiers on chemistry 23.
A day without prayer is a day without blessing, and a life without prayer is life without
கடந்து சென்றாலும் நடுவே நடந்தாலும் புயல் சூழ்ந்து எழுந்திடும் காரிருளை நீ கடந்திட நேர்ந்தால் கடந்து சென்றாலும் நோடு நடுவே நடந்தாலும் புயல் சூழ்ந்து எழுந்திடும் காரிருளை நீ கடந்திட நேர்ந்தால் கடந்து சென்றாலும் நோடு நடுவே நடந்தாலும் புயல் சூழ்ந்து எழுந்திடும் காரிருளை நீ கடந்திட நேர்ந்தால் கடந்து சென்றாலும் நோடு நடுவே நடந்தாலும் புயல் சூழ்ந்து எழுந்திடும் காரிருளை நீ கடந்திட நேர்ந்தால் கடந்து சென்றாலும் நோடு நடுவே நடந்தாலும் புயல் சூழ்ந்து எழுந்திடும் காரிருளை நீ கடந்திட நேர்ந்தால் கடந்து சென்றாலும் நோடு நடுவே நடந்தாலும் புயல் சூழ்ந்து எழுந்திடும் காரிருளை நீ கடந்திட நேர்ந்தால் கடந்து சென்றாலும் நோடு நடுவே நடந்தாலும் புயல் சூழ்ந்து எழுந்திடும் காரிருளை நீ கடந்திட நேர்ந்தால் கடந்து சென்றாலும் நோடு நடுவே நடந்தாலும் புயல் சூழ்ந்து எழுந்திடும் காரிருளை நீ கடந்திட நேர்ந்தால் கடந்து சென்றாலும் நோடு நடுவே நடந்தாலும் புயல் சூழ்ந்து எழுந்திடும் காரிருளை நீ கடந்திட நேர்ந்தால் கடந்து சென்றாலும் நோடு நடுவே நடந்தாலும் புயல் சூழ்ந்து எழுந்திடும் காரிருளை நீ கடந்திட நேர்ந்தால் கடந்து சென்றாலும் நோடு நடுவே நடந்தாலும் புயல் சூழ்ந்து எழுந்திடும் காரிருளை நீ கடந்திட நேர்ந்தால் கடந்து சென்றாலும் நோடு நடுவே நடந்தாலும் புயல் சூழ்ந்து எழுந்திடும் காரிருளை நீ கடந்திட நேர்ந்தால் கடந்து சென்றாலும் நோடு நடுவே நடந்தாலும் புயல் சூழ்ந்து எழுந்திடும் காரிருளை.
Professor Murugu Raja, participants, and my dear students, very pleasant good morning to all. Now it is the moment to express a happy attitude one and all present here, that is welcoming the attitude which speaks well of the one who gives and the one who receives it. To express that attitude, I have been assigned that pleasant duty. I am delighted to welcome all for this gathering of 2 days international conference on expanding frontiers in chemistry, EFC 23. The conference aims to providing platform to the students, researchers, and academicians to share their knowledge and ideas in their respective field. Having this PG Department of Chemistry, Arul College has been arranging the international conference since 2001 onwards. First of all, I am extremely honored to have the chance to welcome Reverend Father Rector. He is an excellent teacher, dynamic personality, advisor, and a great inspiration for the faculty and the budding scholars. Dear Father, it's my honor and my pleasure to welcome Reverend Father, who has been a source of inspiration through his positive energy and words. Father is an excellent teacher of literature, a dynamic personalities, and a great inspiration of our students. I wholeheartedly welcome you, dear Father. Today's speaker, Dr. Raja, Professor and Head of Chemistry, Central University, Kasaragod. He is a person of inspiration, highly resourceful resource person. Just now, I spoke with him. He expressed COVID-related major 3 projects, and he is also working on it. His research is highly commendable. Such a nice person is going to address for the inaugural address. He is going to share his knowledge. In this regard, I wholeheartedly welcome behalf of management, behalf of Department of Chemistry, behalf of faculty, students, I wholeheartedly welcome dear sir. I am glad to welcome the professors from other colleges, universities for their presence this mega event. I welcome dear professors. I feel very happy to welcome the faculty members of Department of Chemistry in our college. Welcome dear professors, colleagues. I would like to welcome the student participants, research scholars from other colleges, other higher institutions who are going to partake in this knowledge sharing event. Welcome dear students and scholars. Last but not least, I welcome the students who are the benefactors of this mega event. I welcome my dear loving students. Welcome students. Once again, I welcome. Thank you very much for this opportunity. Thank you.
Thank you, sir, for your words of welcome.
We invite for the short regarding life journey. Following the principal. And then after Google over the other. Actually, after that, finally, the capability of the government is then
Thank you all. You inspire before you expire. Here comes a fountain of inspiration May I now invite Father John Prakasa to felicitate us.
Secretaries, respected professors, faculty members, invited speakers, faculty members from other colleges, my dear students, participants of this international conference, good morning to all of you. Very happy to stand before you once more and felicitating you for the international conference that you are going to attend today and tomorrow. It's a very important activity of the department once a year to conduct this, what they call expanding frontiers in chemistry. Both these words, expansion as well as frontiers, denote dynamic movement. There is no end to expansion like our universe going on, expanding, no end to it. Same way, there is no end to learning something new in chemistry. Same way, where is the frontier? Frontier means the border. There is no border to one's own learning. Just now I had a small conversation with our chief guest today, Principal Office, where he was talking more about learning and teaching in our schools and colleges. Many of us known for teaching the subjects, but rather than teaching the students how to learn, we were very much talking about the process of learning. Only we can teach our students how to learn the proper way. We don't need to really teach the subject. They will learn on their own. These days, because of the internet, the facilities available to Google, many students, they won't learn the subject. But unless there is somebody who teach you how to learn the right way, we're wasting a lot of our time. That way, our chief guest today is a person expert in this area, and I'm sure he will share with us some points on this area of learning and teaching. I'm very happy to be here today because the chemistry department here is a very active, dynamic department. Lot of activities throughout the year. So much so sometimes I told my students, because some of them will be missing from class because of outside activities related to the department. But that is part of our learning process. Not enough to learn from the books or from the teachers, we also learn from other sources. That way, having a conference like this being conducted by the students as well as faculty members is a learning process for all our students. So that way, an opportunity for our students every year to exercise their creativity, their new ideas into practical way. So I wish you all the best. So these 2 days will be an enjoying experience for all of us, particularly for those who have come from outside the wonderful campus. So enjoy your time here. The free time you can go around, relax a bit, because it's a beautiful green campus. God bless you. Thank you for the opportunity.
Sorry. Frequency. Turn on the lights within. Expand your horizons and reach your full potential. Every morning is a new opportunity to enrich our lives and to understand and expand the best. Respected Reverend Director, Dr. John Pranasam, Dr. S. Rayapan, the head of the Department of Chemistry, the chief guest and the resource person, one among the resource persons of the day, Dr. K. Murugapati Raja, Professor, Central University of Kerala, Kasaragod, professors and research scholars from our college and other colleges, and my dear and dearest beloved students of our Department of Chemistry, the future leaders of the society. A very good morning to you all. At the very outset, I express my loving greetings and blessings to all the participants and vibrant students of chemistry of this spectacular international conference on expanding the frontiers in chemistry. It's a pride and a privilege to address this August gathering and to say a few thoughts of mine for no chemistry knowledge. I want to bind them, a little afraid. Very scholars, all our scholars, including Miss Selvi, the student union person, our different. எல்லாரும் லைட் ஏற்றிட்டோம் ரெண்டு லைட் கம்மியாயிடுச்சு டிம்மாயிடுச்சு அவங்க என்ன செய்யறாங்கன்னா மற்றவங்க லைட் அடையக்கூடாதுன்னு எங்க லைட்டை சேர்த்து ஏற்றி வச்ச ஒரு மகா செல்வி அவங்க on the stage over a variety of persons. ஒரு இடத்துக்கு ஒரு ஹெட் தான் இருப்பாங்க. ரெண்டு ஹெட். The head of the institution himself is the Department of Chemistry. I really salute the department. The head himself is one among the subjects of the department. And we have Arul, who is Rayapan, teacher. The church itself is going on. Herself is going on. And we have Dr. Rayapan beautifully leading the department. Let's give a round of applause for him and the team. And today we have one more wonderful person, Dr. Bhupati Raj. Okay. Country சொல்லிட்டு beautiful land நம்ம முருகன் அங்க போயிருக்காருன்னா certainly you have to give a round of applause not only for the greatness within him but also Bhupati என்றால் நான் இங்கிலீஷ் தான் பேசுறேன் சரியா Bhupati the earth Raja Raja Bhupati in the field of chemistry. We had a very short, as far as rector said, we had a very short but the moment we talked with him, it was an inspiration for myself. You and I have to learn from persons. It might be simple persons, it might be great persons, but each person is different because he or she is in that particular field. I respect you because I am sure you people from the Department of Chemistry are more knowledgeable in chemistry than myself. And it might be balanced equations or mixing of acids and alkalines. I do not know what the subject. எனக்கு வராத subject ரெண்டு. ஒன்று வந்து mathematics. ரெண்டாவது சொல்லலாம். I don't have a success story in chemistry. But today I feel proud to stand before you and share a few thoughts of mine in the field of on this day of international conference on expanding the frontiers in chemistry. You and I need a platform. You and I need a platform. கொஞ்சம் யோசித்து பார்க்கிறேன். You had some time ago we had mechanical clock. Yeah, mechanical clock. இந்த காலத்து ஆளுங்களுக்கு அது தெரியவே தெரியாது. வைண்டிங்னா என்னன்னு தெரியுமா? 2K kids. வைண்டிங், WIND. நிறைய பேர் இங்கிலீஷ்ல எப்படி வாசிப்பாங்கன்னா விண்டிங்னு வாசிப்பாங்க. இந்த வைண்டிங்ன்ற வார்த்தையே இனிமே இந்த ஜெனரேஷனுக்கு தெரியாது. 2K கிட்ஸுக்கு தெரியாது. வைண்டிங்ன்ற டெக்னாலஜியே போயிட்டு அது சாவி கொடுக்கறதுன்னு, சரியா? அது போயிடுச்சு. 2K கிட்ஸுக்கு அது தெரியாது, சரியா? எங்க வாத்தியார்லாம் இப்படி காதை திருக்குவாங்க, வைண்ட் பண்ணுவாங்க. நாங்க சவுண்ட் கொடுக்கணும். சவுண்ட் கொடுக்காம பொறுத்துக்கிட்டா இன்னும் திருக்கிட்டே இருப்பாங்க, சரியா? கெமிஸ்ட்ரி காது வாங்கி வாங்கி அவ்வளவு நீட்டமாயிடுச்சு. வைண்டிங் என்ற வார்த்தையே தெரியாது. Afterwards you had this alkaline batteries. Alkaline batteries உள்ள போட்டாங்க. இவ்வளவு பெரிய பேட்டரி 2AA என்னென்னலாம் போட்டிருப்பாங்க நமக்கு புரியாது. அந்த பேட்டரியும் போயிடுச்சு. Then I think you had quartz coming in. Quartz. அப்ப நான்லாம் வாட்சை கட்டிட்டு இருப்போம். குவாட்ஸ் அப்படின்னு எங்க அண்ணன் சிங்கப்பூர்ல இருந்து அனுப்புவான். அப்ப எங்க குவாட்ஸ் வாட்ச், சிட்டிசன் குவாட்ஸ் வாட்ச் அப்படின்னு எல்லாத்தையும் காட்டிக்கிட்டு இருந்தேன். இப்போ குவாட்ஸ் போயிடுச்சு. அதுக்கப்புறம் it came digital technology came inside, and what not, one after the other. Today they speak of nano technology. நானோ எனக்கு தெரிஞ்சதெல்லாம் டாட்டால ஒரு நானோ கார் போட்டாங்க. 1 லட்சம் ரூபாய்க்கு ஒரு கார் போட்டாங்க. அந்த கார் மட்டும்தான் எனக்கு நானோன்னு தெரியும். But today I learned great things from nanotechnology. My dear friends, I just take this cell phone in my pocket, okay? ஒரு 10 வருஷத்துக்கு முன்னாடி என் டேபிள்ல வந்து பார்த்திருந்தீங்கன்னா I had a typewriter on my table. I had a tape record on my table. I had my music set with earphone on my table. I had a calculator on my table. I had a notepad on my table. I had so many different. I had a camera on my table. So many things I had on my table. இன்னைக்கு என் டேபிள்ல வந்தீங்கன்னா my table will be plain, simple. ஒரு செல்போன் என் டேபிள்ல இருந்தா போதும். You have camera inside. You have notepad inside. You have calculator inside. You have VCD player inside. What not? எனக்கு தெரிஞ்சே 34 ஸ்டெப் இதுக்குள்ள இருக்கு. ஆனா இன்னும் நம்ம என்ன செஞ்சுட்டு இருக்கோம்? கால்குலேட்டர் வச்சுக்கிட்டு தான் நம்முடைய வேலையிலாம் இன்னும் நம்முடைய செல்போன் வச்சுட்டு தான் இருக்கும். You and I have to think ahead. Otherwise, this world, the present will accept you. If the future wants to accept you, you need a platform to think wide. இன்னைக்கு ஜெனரேஷன் திங்க் பண்ணாதத, only dream பண்றத you and I have to do. You and I have to invent. You and I have to innovate. Only then things are possible for you to go on. நாங்க தப்பிச்சிருவோம். நாங்க இன்னொரு 10-20 வருஷத்துல ரிட்டையர்ட் லைஃப் வந்துடும். But you are the future citizens. You are the future leaders. And you are the future scientists. And you need a platform to excel and to fly high in the sky. And the department of chemistry is giving you a platform. For an example, நான் வந்து உங்கள்கிட்ட கேட்கிறேன், இந்த பாட்டில வச்சு நீங்க என்ன செய்வீங்க? உடனே நீங்க என்ன சொல்லுவீங்க? தண்ணியை ரொப்புவோம். After that, what will you say? அந்த தண்ணியை குடிப்போம். அதுக்கப்புறம் என்ன செய்வீங்க? எங்க காய்கெல்லாம் கெமிஸ்ட்ரிலாம் நாங்க சொன்னா பக்கமா எடுப்போம். அதனால நாங்க காயை கழுவுவோம். வண்டர்ஃபுல். அதுக்கப்புறம் என்ன செய்வீங்க? Perhaps என்ன செய்வீங்க? குப்பையில தூக்கி போடுவோம். This is all you and I think. But a man of imagination, a man with little bit of technological skill, will go one step higher. He or she will think that this can be used as the funnel. அத பாதியை கட் பண்ணிட்டு கீழே உள்ள மூடியை எடுத்துட்டா we can use it as a funnel. ஒரு இக்காலஜில படிக்கிறவங்க இது பிளாஸ்டிக் கெட்டு போகாது தெரிஞ்சிருந்தாலும் he or she would use it as a garden. மணி பிளான்ட்லாம் தொங்க விட்டுருக்கிறது பார்த்துருக்கேன். இன்னும் நல்லா திங்க் பண்ணீங்கன்னா ஒரு சைல்டு இதை கொடுத்தீங்கன்னா யூ கிவ் த பாட்டில், அதை அப்படியே ரோல் பண்ணும், கீழே ரோல் பண்ணி அதை ஒரு 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 மெக்கானிக்கல் ஸ்கில்ஸ் அதுக்கு இன்ட்ரடியூஸ் பண்ணி the child will have her own technological skill. இன்னும் நம்ம ஹாஸ்டல் குழந்தைகிட்ட கொடுத்தீங்கன்னா இதை தூக்கி ஒரு வெப்பனாவே என்ன யூஸ் பண்ணிடணும். He or she can use it as a weapon. Sometimes he or she can use it even for imagination. சின்ன குழந்தைகிட்ட கொடுத்தீங்கன்னா he or she will say is a rocket. தண்ணி அடிச்சுக்கிட்டே அவன் செய்து காட்டுவான். It can be also used as a rocket. All that it is your imagination, your dreams should have a platform. The Department of Chemistry is giving you an opportunity, is giving you a platform to see different varieties in the field of chemistry and how you can all achieve. So far, you were glued in the classes alone or in your laboratories. But now is the time you have experts from national level and international level. Some will be on the stage, some will be off the stage, and some will be virtually available for you. Use this opportunity, because this useful opportunity cannot be again got back. For 3rd years, for example, you cannot get back this opportunity. I think that this great man was come here, Dr. Muruga Bhupati, himself is an example. நம்ம ஊர்ல பிறந்தவர் தான், மதுரையில பிறந்தவங்க தான். நம்ம பக்கத்து நாகமலை புதுக்கோட்டை, சார் போகப்பட வேண்டாம், ஸ்டூடெண்ட்ஸ்க்காக சொல்றேன், நம்ம நாகமலை புதுக்கோட்டையில் இருந்தாங்க தான். இதே யூனிவர்சிட்டி, மதுரை காமராஜ் யூனிவர்சிட்டி தான் he went on. When you and I were we closed ourselves in COVID. I think he has got 3 projects for COVID realization, and he has done great work even during COVID. And after that, he has gone to country, Kerala, and I wish, sir, you go not only to Kerala, to Boston, to Singapore, to other places, telling that Tamilnadu முடியும்டா அப்படின்னு காட்டுறதுக்கு we have to start right from this great person, and I'm sure you have right your persons with you. On this wonderful day, I once again wish you all the very best. I ardently hope the deliberations of this fantastic conference will be a valuable and memorable asset for all the contributors, our own institution, as well as other academic research bodies. As the principal of this 53-year-old college, which gives me an opportunity of quality education to the rural poor, I deem it a pride and pleasure to appreciate and encourage the Department of Chemistry under the able leadership of Dr. S. Rayappan and his team, and a wonderful experts, such new and daring ventures in the growing tree of chemistry. May the Lord, the creator and master of the universe, continue to bless and inspire you and all those around you to create a better and magnanimous world that could promote love, peace, justice, and harmony. God bless you all. Have a great going. Thank you.
Thank you, Father. It is the time to honor the chief guest. May I now invite Father John Prakasan to honor the chief guest. We invite Father Principal to present the Anandar to Dr. Muruga Bhupati Raja.
Fathers, I perceive an sun is the earth, and stars virgin. Comes the land of perseverance, and privileged to welcome and to demand never letters.
Morning, everyone. Morning. Good morning. Thank you very much for this what is why called first of all, I would like to thank all the wonderful and all the faculty members and wonderful opportunity to all in person. I'm going to give a talk. I'm going to some something is very important because inaugural address will be validated address the one which is actually we will tell you some important about which would be really useful. So there are with respect to chemistry expansion. Other than studying chemistry, we must really move on to going to learn programming Python. But without artificial intelligence, and we must really, if you have not studied biology, you must really study biology. This is the but if you are staying in the center of science, you will not able to expand. So we must want to this is biology and mathematics, science. And next important thing is material sciences. So many of the talks, and also you are already aware about. But what is very important is or which has more demanding in the present and also going to be even more demanding in the near future. And environment. I don't know whether point or not, there is a concept called and plan together as this. So everything is interrelated with all these concepts. So I would trust you to really one side so that you will really understand opportunity. For students, those who don't want to continue study, there are exciting opportunities if you are interested in government and also other agencies or agencies. Now you don't need any money to start a so these concepts we brought and sort of wonderful capitals and very high. So what is very important is so it can be divided into four. So whatever you are learning in college, actually one course, but really learning. Otherwise, so that is hard field, and we focus on or equip yourself with soft field. Something you might be aware, or some courses you'll be running, and another quarter is really determines where you are heading. And the one is very important. If you are the choices you make in your life, every moment, your life, so the choices which you are making at every point of time is very crucial on your direction of life, your personal life. That's something very important. So I'm we must really learn from anything around you. you're not a learner, then you're going to stagnate. So there are, when we learn and cooking, also this three process. Learn, you should really watch yourself. Don't observe yourself, you will not be really progress. If you want. And we start. Every one of us, you want to have at least two. What is the property of a torchlight? Where we use torchlight to see the things in dark. So we shine a light some distance after the light. The other one is laser light. I'm sure you point to your screen. What's the property of laser light? You are all physics students, I mean chemistry students or science students. So, what is the characteristic of a laser light? For example, we have a red laser, green laser, blue laser. What is the coherent and monochromatic? So, we can use laser even for surgery or even to keep the or break the metal. So, we get that energy only because of coherent together. We take the target and they translate it. So when it comes to business, that means your studies or career, we should be like a laser light. So you can, you know, but when it comes to your personal life, you should be like translate, you should be general. But many times we need to check this light. When it comes to career, job, no focus. When it comes to personal life, you are so focused, you are not at all generous. So we should be very conscious about using this tool light. This is my original idea, so you won't see it anywhere in the book. So whenever in every situation, we should be really conscious about using this light. Personal is a life or business or career or professional. For personal, we need that. Right? We also talking about stop here by the saying. Thank you very much for this opportunity. So, in my opinion, we have only three kind of people: learner, who is learner, we always say learner, professor. That means learn fast and over. Learning continuous process. You are in this. Rest doesn't matter if you exist or not. So now you should be, you should really watch where you really stay. Because in every field, only 2% of the people really lead rest of the 98% of the every field. The choice is yours. Whether you would like to be in that 2% or rest. There is nothing wrong or right. But, okay, thank you very much.
I really like the two lights. We jump to a light on the conference is the chief editor is Dr. S. Simon, editors are Dr. Koya, Vidyaja, Dr. Malkas. The conference proceedings times 7 invited lecturers, 4 from Indian researchers, 3 from abroad. We have received 81 abstracts, 4 for all, 2 for post presentation. We are one abstract from Manas University in Malaysia, 2 two from the National Highway University of Technology, Taiwan, in Anandar. Be on the stage. The lecturer will release the conference abstracts. The first copy will be received by Dr. Nurupati Raja.
Thank you all. We are really thankful. What do you do?
வாய்த்தூக்கார் செய்த உதவி நயன் தூக்கி நன்மை கடலில் பெறுவி என்னன்றி கொண்டார்க்கும் உய்வுண்டாம் உய்வில்லை செய்நன்றி கொண்டார் மகற்கு. Yes, it's very much felicitous to thank the deserved who helped a lot for this today international conference. Foremost, I thank the Lord Almighty for his power of blessings. As we know, the aqua regia, ராஜத்ரவகம் சொல்லுவாங்க. ராஜத்ரவகம், in which almost all the metals are dissolved. The same way, all the human beings, whoever may be the person, whatever may be the heart, will be dissolved in his love and compassion. Is none other than our lovable Rajatravaham, Reverend Dr. Rector S.J. Arul College, Karumathur. Thank you, Father, for your presence and the gift, Father. A base is a donor which furnishes OH minus ion, donating electrons to make a bond, formation of molecules, salts, etc. Yes, whenever we meet the person, he fulfills our needs with his helping hand. Yes, he is none other than உதவிக்கரம் ஈட்டும் செங்கை செம்மல் ரெவரண்ட் டாக்டர் செக்ரட்டரி S.J. Anandar College, Karumathur. Thank you, Father, for your financial support. An acid is a acceptor which always furnishes H plus ion, accepting electrons. Without this concept, H is a Karumathur for accepting the electron. Thank you, Father. When an acid is titrated with a base, neutralized and forms salts, very stable salts like NaCl. Likewise, with a stable mind, a stable heart, neutralizing everything, both the positives and negatives, கடமை, கண்ணியம், கட்டுப்பாடு, விடாமுயற்சி ஆகியவற்றை தாரக மந்திரமாக கொண்டு மாணவர்களின் வளர்ச்சிக்காக பல முயற்சிகளை எடுத்துக்கொண்டிருக்கும் நம் துறை தலைவர் டாக்டர் S. ராயப்பன் அவர்களுக்கு நெஞ்சார்ந்த நன்றி தெரிவித்துக் கொள்கிறேன். In chemistry, there is host-guest compound, which is a special one, a peculiar one, a unique one with a different properties. Yes, we have guests among with us to be caged with AAC by sharing his knowledge with our students. He is not somebody else, but our chief guest, Dr. K. Bhubati Raja, Professor, Central University of Kerala. Thank you, sir, for your acceptance. Periodic table constructed mainly by 4 blocks, S, P, and M. Likewise, இந்த விழா சிறப்பாக நடைபெறுவதற்கு மிக பெரும் தூண்களாக இருந்து செயல்பட்டுக் கொண்டிருக்கும் எமது துறை பேராசிரியர்களுக்கும் மற்ற கல்லூரி பேராசிரியர்களுக்கும் எங்களது மனமார்ந்த நன்றியை தெரிவித்துக் கொள்கிறேன். எஸ்பெஷலி ஐ வுட் லைக் டு தேங்க் வருஷத்துக்கு 5 முறை அடுத்தடுக்காக கான்ஃபரன்ஸ் வச்சாலும் அசராம சொல்லி அடிக்கிற கில்லி ஒரு மேக்னெட் பார் இந்த ஆர்டிஸ்ட் செக்ரட்டரி டாக்டர் எம் அமல்ராஜ் அவர்களுக்கு நன்றி சார். For your tireless effort and hard work, sir. Finally, I thank all my dear cadres and audience of chemistry department and other ions of other colleges for your active participation. Last but not least, I also thank from my bottom of my heart to the
sponsor, Dr. Jagdishwaran, our alumni, the owner of Biome Technology, Karupudi, for sponsoring the national conference, international conference bags and all. Thank you, sir. I also thank Mr. Sahai Raj. Sir is sponsoring us the notebook from Xavier Notebook, Madurai. Thank you, sir. I also extend my thanks to the students of campaigning committee and invocation and the video, audio, visual technical committee.
For the first invited talk by Professor Dr. K. Murugapurupadi Raja, was our chief guest this morning. We have the taste of work, how much he brings this conference. As I have gone through the various invited talks, I come to the conclusion that the development of therapeutic peptides for Alzheimer's disease, computational and chemical biology approach. And if you have some other topic like organic electronic devices, organic light emitting diodes, so one's electronic nature, and then you have latest advancements in wastewater treatment technologies, down to earth research, how to purify water, and then another example at the end is light harvesting devices and materials, good trends and applications. So, wide variety of topics, even though common platform is chemistry, a wide range of topics pleasing to everyone. Not only because it is pleasing to everyone, but so today people don't look at chemistry, physics, math, computer as separate topics. They are all integrated. Professor himself has chosen a topic which involves chemistry, biology, biophysics, and then computer modeling, and so on. So he touches upon and forget about other areas. So you need to be knowledgeable in a wide variety of subjects in order to make a meaningful research. Remember, two of the famous actors, American actors, had this Alzheimer's disease. President Ronald Reagan was originally an actor, then became a politician, finally two-term president of the United States. He suffered from Alzheimer's disease. He even forgot his own wife's name. That much is the tragedy of people having Alzheimer's disease. That is memory loss. Basically, start losing your memory. That means brain's activity is minimal. That way, lose memory and lead with tragic ends. Very unfortunate, but and also how you can use computer modeling in order to address the issue. And some of us, as we get old, lose our memory. I myself forget very often what I did 10 minutes before. Sometimes I switch on the geyser. After 5 minutes, I have my doubt whether I put on my geyser or not. Only 70 years old, already I am feeling loss of memory to some extent. But memory loss need not be attributed only to Alzheimer's. There can be other reasons, but there are symptoms as you get older and older. Particularly, it has become women for Indians. So women live longer than men. As they get older, they have to go through this. Some of them, Alzheimer, losing their memory. So, professor will be addressing important issue, biological and chemical issue, and open our eyes and minds to this new topic. And we are given 1 hour, sir, 45 minutes of presentation.
Can you all bend to your right? Bend to your right. Don't fold your hand. Don't fold your hand. Just keep it loose. Bend to your left. Now, why do we need this one? If we don't touch the mouse of a computer or a pad of your laptop, after some time you go to sleep mode. And so if you don't shake your body, your CPU will go to sleep mode. So I don't want to talk to sleepy people. Right? And also it's very important, you need to be alert, especially if you want to learn about Alzheimer's disease. How many of you know about Alzheimer's disease? This method was invented because many times when we don't answer, not because we don't know, because we don't concern about or worried about what others think about. Those we can kind of in a safe mode. All right. So today I'm going to talk about sustainability and work which we have been doing last year. Small group in Madurai University, now almost doing reading the thesis. And then hope you must go to Central. So research interests actually centered about peptides and peptidomics. I'm pretty sure you all know what peptide. What is peptide? This is high school. What is peptide? When you link two amino acids together, carboxyl group and amino group condense together by using a water molecule, it forms an amide bond. This is the only bond which present throughout the peptide and proteins. We call this the peptide bond. Peptide bond is nothing but an amide bond, C1H linkage. So the longer peptide having several amino acids stitched together, call it a protein. So protein, the protein block or the actors of our table. Those who write the script, because it's RNA and DNA, they write the script. Proteins, they act that they will give you the function. So our area is the peptides and peptidomimetics. Peptidomimetics, they mimic like peptides, but in essence, they are not peptides. And also some other organisms do not have a nucleus. They do not have the codon, and they have some other amino acids. We have about 20 plus amino acids, sorry, codon or amino acids. Other than that, we call it non-natural or non-chloride amino acids. Work on self-medicating peptides, ligands, or inhibitors, fibrils, especially foldamers and folded unique structures. It is not material. By chemical method and biochemical method, then we use largely almost all they do not have a codon, but also we can make different like diamide, N-alkylation, also dehydroamine, alpha, these kind of amino acids are very useful when we are designing the drugs, because they cannot be cleaved by the proteases, which will be shoot out for. So these are the projects. So now we also work on I will touch upon this one material for delivering and also vehicles to transport this molecule across the blood-brain barrier. DNA. DNA translated into RNA. So DNA is and which is translated into a single strand. Once the single strand RNA translated or translated into protein using a molecular missionary called and this protein based on different type of amino acids, we start folding into a very different structure. And now we look at this one as the typical thermodynamic So this need to really overcome this barrier. So it is a protein. Which are functional, they are quite native in nature, meaning they are foldable and they have biological. These protein structures can be determined by only atomic resolution structure only by two methods. One is single crystal authority and the is matrix. These are the two methods which will give the position of atom. Equilibrium between two and four, and so this is where the problem. So if they don't put it completely, and it so if you look at the biochemistry or biological question, you will see the protein structure of different shapes or sizes. They all do different. And this 1950s, all textbooks now this is what the cell ratio. However, in 19, the first model of DNA has been made by one protein structure and 19 by structure in 19 this bigger complex structure than the X-ray shows. And that's the order of structure. It doesn't follow processes actually some proteases or they can be into molecular dictionaries and then they import it. Or if they don't actually or import it. Still, there are they go they become a soluble polygomers, then or irreversible. Each stage and they start forming. Hello. Also, if you go to or they don't fold properly, they actually came up to cell death by forming for formation and so on. And this accumulation of this protein causes diabetes. So it's important to understand how we can actually control. So our idea, lab idea, is the mechanism of this study and design molecules specifically to break this interaction so that we can actually have a protection molecule. These triples are quite toxic. Why they are toxic? Because once they fold it only, properly only, they have a function. They don't fold it, they actually accumulate and they become like a so they actually diagnosed, he has been diagnosed. On the doctor. This is the recognized at global context. Now, if you look at this one, in 2030, about 35 million people are expected to have more than half that's in Asia. So more people like only developed countries. Now, India is the youngest country. That means we have a huge population. However, after 30 years, we have a huge older population. Why? Because our life expectancy is much better. So we will live longer. But the question is, do we live healthy? Do we active? At least, right. So now this is the stage. For women, it is one is there is more prevalent, whereas men for every 11. So it's also very important that we should. So what is dementia? Dementia, memory. I could actually recollect in school biology or school would have studied about neurons. And now they fire this electric cell the communication. This firing small LED. Now, if they fire together, they are if they are wired together. So the brain will be active if the signals are keep on transmitting each other, so the connection will be established. So then if there is any damage in the connection, then that part will function. There will not be any. So this is the so if the if when this let's will actually do this causes depression, medication due to various side effects. You're taking some medicine for excess or long time. So now Alzheimer's, much later stage, after the all this happens, what the could actually mental brain. So we need mental muscles. So we keep on working on everyday muscles or to attend. And symptoms of cognitive, behavioral level, mood, and psychological emotions. So this is quite very diverse symptoms. Cognitive level, mental level. So they cannot do even math, and understanding. So and also behavioral level, they are quite aggressive, self-care. So now molecular level, what happens? We look at the brain, it's affected. This is to see amyloid kind of thing, and you long tangles actually do work application of a how to be. And then amyloid plates actually from a bit of which aggregates, and that's what. So these are the very important targets. But so called amyloid receptor protein by acting enzyme alpha cyclic. And from like 40 to 42 specific peptide, it starts aggregating. They form triangles of prototypes or or fibrils. So inhibit this step so that we cannot protein or protein and down protein. So we our target is the so amyloid fibrillary is something quite common in all treated diseases. Our target is actually the production of by inhibiting or and or we can also approach synthetic. For example, here we have some molecule which does not allow them to aggregate, then they can also molecule or small molecule, but it is sometimes we have a crystal structure. Two forms. Open every enzyme has a kind of breathing property. They allow the substrate to go in and insert or do whatever or transit and throw this product. So the enzyme, which is the open form, then this is the form and this is the body. Now, what are the targets for one, we have, as we know, this production of or targeting under this by stopping this power or this plus there are some which coffee. And another is quality of the coffee dish. So there is independent design. So there are predominantly useful for so how this baby development thereby to so what are the advantages and disadvantages of going to the now for several years we have been working in collaboration pioneering and there is endosomal targeting so in 2006 published where we are able to show is secretes in brain as well as secretes in. Now, if we inhibit this enzyme, then this also will not operate in kidney. This is a problem. We will go and bind to this beta cyclase enzyme too. Now, this is a problem. So now, how do we selectively inhibit beta cyclase, which is secreting crossing the blood-brain barrier? Because any molecule which is going to reach this brain, for example, you take any molecule where we have a bloodstream, we can actually make sure that they reach the organ. For example, you take any injection tablet, how it will reach to particular place because it will go by bloodstream and other mechanism. Whereas you take, if you want to target anything in the brain, then you need to pass through blood-brain barrier. Why? Because now brain is made up of very, very hydrophobic material, very packed and all that. So it cannot really pass through. So we need to really have some methods or mechanism to deliver specifically to brain. So that's a challenge. So we analyze this. So generally our approach is to first we actually see what is the present knowledge. We analyze, we do quite a bit of bioinformatics and cheminformatics to understand what is already there, can be done something. So we analyze all the crystal structures which is bound to this beta cyclase enzyme. Over 450 crystal structures are there. And now this APP peptide which is produced, APP peptide produced from it is in a collaboration with Professor Lawrence Rajendran. And we designed several molecules using molecular dynamic simulations. And these molecules having a non-peptidomimetic moieties in the center where it is getting cleaved. So we replace this amide. Alphases clearly show they actually have a quite good binding affinity at a non-amyloid substrate compared to NGR, NRG, and L1. These are another two proteins which also compete with this beta cyclase. So after several biochemical assays, okay, and we also showed how this could be penetrating into the cell at the endocyte. And how do we take this molecule specifically to the site where it is? Now what we have done is we have attached sterol or a cholesterol molecule with the tall link. Then we actually take them into the cell. I mean, it goes and insert into the membrane and thereby it is access to this one. So I'm just keeping because a lot of biological experiments to prove that they cleave specifically at the endosomal site, which is published in 2016. So I'm just summarizing from that paper. It's a collaborative work between Sweden, Germany, India, many laboratories across the world. So although APP is amyloid precursor protein, processing by beta cyclase enzyme requires endocycles, it is inside the endosomes, and therefore encourage the possibility that if we target this molecule at this compartment, then we will not affect the same beta cyclase which is in the liver. So this is a very important invention for these names. So which is also got quite a bit of because it's a breakthrough paper. It's the first time we showed that we could specifically specifically target this one. So we had a huge newspaper coverage and this one across the world. So now, after that, we got our own project funded by SCRB, where we started designing molecules which are specifically, cleaves or inhibits intercyclase. So our strategy is to use fluoro pad in this one. If it is cleaved, then we will see a fluorescent imaging or emission. If they don't cleave, then they will importantly use not gamma amino acid but a delta amino acid, very mimic of dipeptide unit isoster. That's why we used our chemistry knowledge to design these molecules, and transition state building blocks, which is incorporated in making peptide, then purified by HPLC characterized by unknown methods. Then we also did a bioassay. So this is quite a complex of organic synthesis involved in making these building blocks, where we have several double bond and OH group which mimic this one. Why? Because in the substrate, what we have is the peptide should not be cleaved in the active site where it goes by. So we also made a peptide with this isoster containing and also linked with the cholesterol, so which is used. Then we are characterized by IR, NMR and HPLC mass spectrometry. And this is a couple of examples. You could see this is we have actually maintaining the side chain, but removing this amide bond where this cleavage is happening. I'll tell you, this is quite challenging business to make this really not very expensive, which involves several laborious steps in typical organic synthesis. Only thing is, it needs large quantities so that we can. And also we did several in silico molecular modeling interactions and so on. And the other project, and we wanted to say, so we made these peptides and characterized by, and also you could see they are random coil structures because of introduction of diamine acids. And what we have done is we have made several class of molecules in a non-cleavable transition state. So we made a library of. So our business is we are expert in designing molecules intuitively, and we make all this library of molecules. So we take a lot of time to really complete our work. But once it is thorough, because we don't, in my opinion, it's my personal opinion, my approach is I don't work for papers. We want a product. Can be at any service. At the end of several decades even, do we have some molecule which transform us a drug? That's what. Not just adding one more paper into the field. So we take our own sweet time to really make molecules and thorough investigation, and there are now patent filing also in progress. We remove NH main or we change to methylene group and put COH so that it cannot be. And we also done, and every time once we design, we do docking, energy, then molecular dynamics, because it is less expensive compared to making the molecule. So we actually make a library of molecules, we screen in vitro, then we select some molecules, we make those molecules because purify because they are expensive. And we go for this one. For example, how we really use computational method. So we study this interaction, how they are, what are the interactions. So can we replace those interactions or make it better, this interaction, by replacing this one. So this is called chemical space exploration. Exploration of the chemical space in the enzyme substrate complex or active site. Okay. So with the different wild type and Swedish mutants, different mutants are there. So we actually use this. So this is an example how we really do it. So, and I'll tell you very hard result. Just only tonight, yesterday night I got this slide. I thought, okay, I'll show you. So these A-beta peptides, independently as a monomer, they are helix. Now we also have NMR structure. A-beta 40 residue NMR structure. This is A-beta 42 NMR structure. It does 3 this. Now what we have done, we used extensive molecular dynamic simulation and come back to this one. So we wanted to actually see what happened, because we want to actually understand how this molecule aggregate over the time, how they changed their confirmation value so that we could actually also make. Now you could also see that table of 42 actually expands because it changes its confirmation. So chemistry, as Dawson said, is the engine that drives biology. If we don't have chemistry, then biology cannot really understand better. So how about Professor Balaram, my supervisor from IIT Bangalore? So he used to say the biology is the fuel that powers chemistry. We can actually progress or understand biology much better if we know chemistry. So those who get this Nobel Prize in biology or medicine are actually more of chemists and physicists, not biologists themselves. So the contribution, we now know much more about medical system, all the healthcare, only because of the contribution from physics and chemistry. Now I'll just keep on to another project which we'll be doing in the laboratory. This is about the protein aggregation. Now I told you, right, if you look at protein, what are proteins? Proteins are like, I have a control. What are the other polymers? Polyester. What is polymer? Same unit repeatedly connected, right? But similarly, proteins also we call it a biopolymer. The difference between this polymer and biopolymer is proteins are heteropolymer. Instead of one monomer, we have several monomer, like 20 monomer. In polymer, we don't talk about sequence. Have you heard about humans, the genome sequencing? Only in protein we talk about sequence. Why? Aggregation and tubular formation. Okay. So we are into understanding this polyglutamine expansion. This is which contributes that. This is which is also genetically disorder. Now, a very important thing is we make, as a chemist, we have a power to make this molecule. So we make this very, very difficult sequences. All the project, whatever we are doing is very challenging. It's not just mixing two, getting something. No, we make single molecule and we allow them to aggregate and be able to elucidate these polyglutamine peptides aggregates into fibrils, annular, and amorphous, and form like a cluster. So now we are able to elucidate the mechanism of this aggregation at a different end. For example, and also we use molecular dynamic simulation modeling to understand the role of flanking residues or neighboring groups. For example, this is 10 glutamine continuously, and this is in extended structure. If you look at this Ramachandran map, and as soon as you add few residue before and after, they started folding into helix. Okay. Similarly, in helix, it started changing into the alpha helix to right-handed to left-handed helix, and from alpha helix to beta sheet and left-handed. So this clearly shows that we could use a computation tool to understand the role of an atomic resolution or residue wise. So we could also generate models and explain. And the other project, as I told you, as a scientist, as a chemist, we took a response because my first postdoc in Singapore, I worked on some biosafety lab. We could not continue in HIV protein or so on. But in the COVID pandemic, as a responsible scientist and citizen, I took the other target is the protease level. Similarly, in SARS-CoV-2, we have 3 protein, main protease, PL-PRO, and so on, protein. So our idea is to really make this molecule which goes and attach. So we design this covalently. So we use chemistry. Michael addition reaction will happen. So there are groups which we attach or incorporated, where this will go and attach to the cysteine molecule sulfur in the active site, 145 or so. So it will go and irreversibly bind. So it's a very powerful method to antiviral. So this also now we have progressed quite a bit, and I'm pretty hopeful that we'll get this one. All right. Now I'm going to last 5 minutes or so. I'm going to tell you even more interesting. This is all research, right? So I'm going to tell what are the opportunities in higher studies and research. If you are a student as well as teacher. Okay. Um, so before that, I will tell you. So I traveled more than 30 countries. I studied in corporation school, Madurai. I studied in Tamil medium corporation school. I'm a very average student. Okay, very average. But because of my BSc third year, I changed my style of learning. I able to even crack, and that year in all colleges I was the topper in the entrance exam. Okay. And I continue to do that because I use my maybe some other time, but it's pretty important that we should really focus on or watch on what we learn or how we learn. Are we really learning or do we making enough progress? Otherwise, we need to really work on ourselves. If you don't work on yourself, nobody will do it. Okay? So, and this is, I'll just show you some to impress you. If you are a scientist, you can actually go to the place where no one can go. For example, if you are not a scientist, you are not allowed to atomic reactors, even if you are a family member. Even if you are a scientist, but your family member. Center for Biomolecular Magnetic Resonance in Frankfurt is a large-scale facility in Europe where they have 18 NMR spectrometer, not UV spectrometer, 18 NMR. Every day for liquid nitrogen itself, they spend like 3,000 euro, only liquid nitrogen consumable. And they have 4 NMR managers, laboratory managers. And that facility, we could actually put a probe, and in the NMR tube itself, we can, just 2 months before he was conferred with Nobel Prize, because each course, only 12 members selected across the globe. In fact, against several and many other courses, like Denmark, Germany, Sweden, Netherlands. So this is a EMBO practical course on single molecule manipulation. The single molecule, if you take one mole, how many molecules? 10 to the power 23, Avogadro number, right? You take one molecule, attach magnetic quantum dots, and use optical lasers, IR lasers, to stitch them and find it. It's called force microscopy, force spectroscopy. So we can measure forces in piconewton, and so that we can actually understand how I understand things and how I translate to students, because you get kind of authenticity. Of course, every course so my classmates, batchmates, these course mates are from very different origin, very different culture, very different countries. Alright. So you could also see it's in magnetic motors, where you could see the changing. So you attach a nano magnet and actually wind them, then switch off, then we can unwinding process, we can measure it and measure the force. In most of the courses, I was the only Asian. Forget about India, I was the only Asian. So many courses. So this is the above practical course on biomolecular NMR in Argentina. Okay. So all these directly we know. So I'm quite and those who have complex about your skin color, you will realize this color has more value. Okay, outside this. Okay, many people ask me, can I take a photograph? They actually want to touch. How you didn't have this? Because we have a lot of these pigments. So the more darker you are, more value. So don't worry. Alright. So, and this is small angle X-ray scattering in the synchrotron facility in Denmark and Sweden. This was my first Christmas. They were professors. Okay. So we were celebrating. And this is the synchrotron facility, Max Lab in Lund. Okay. And it's Russian, Ukraine actually. He was teaching how to drink vodka. Okay, you end up learning everything. And this is the practical course on computational RNA biology after I joined here. This happened in Croatia, where Napoleon is born. So if you are a scientist, you end up actually traveling more places. You are a good scientist, you are very particular about it. And also I had an opportunity to spend time in Oxford. It's a dynamic lab synchrotron facility where we had, and this is Oxford University LMB Laboratory for Molecular Biology. In one building, 14 Nobel laureates. That time, so one building, 14 Nobel. That means when you go for a coffee, you end up hitting an overload. You go for a lunch, you so the knowledge transfer experience, the way you think, everything will change. That's why you need to really go to prepare issue and so no pain. Okay. So I will. So it's also listening. So, so in this animation you would have learned. Now the problem, it's very relevant because you don't say it complete. Because we want lighter. But that lighter is going to affect you someplace where you can't even use this degree itself. So I really request all of you to really be careful on making choices. That's why I told you. Making choices is very important. Then, what is the formula for success? Hard work. Before hard work, work. Hard work. Then what? What is smart work? Not doing work yourself. That is smart work. No. So work, hard work, untiring work. உழைப்பு, கடும் உழைப்பு, அயராத உழைப்பு. So if you don't give up, then only we can succeed. It's not just work, the hard work. No. We should not give up till the end. That's untiring work make you successful. Whatever you do. Right? So I'll tell about this. This is my so I always get some summer students. Every year I get a lot of summer students from even North India or many things. Okay. So these are the higher studies fellowship. You can make a note. Don't take a photograph. Just write this. If you are taking a photograph, never going to see it again. Because we take several hundreds of photographs, we forget actually. We think it will be useful one day, but we never use it. So in India, you must clear CSR net. Why? It is as good as having a job in your hand because you get 31,000 plus HRA, like 35,000, which you will not get even if you go for a job. You will get only 20,000 plus. But if you are having a CSR net clear, then you will get 35. And yet, it's a national standard, and you are above national standard. Then IIC and ICER and MHRD, SCRD, DTP, ICMR, there are a lot of fellowships are available which you can start in Singapore and Brain Pool in Korea and Taiwan. Many other fellowships are available. So these fellowships are, and some fellowships are even for teachers. If you are in a college or the proficiency is very important. Otherwise, you will have a degree, it's of no use. Will not be able to. So I also should request head of the department and other faculty members. I don't see them except so to take care that you should become familiarized or up to date with the current scenario in the field. Okay, because you want to. And also it will give a lot of job opportunities. You will get linked, very important. And since if you are a chemistry student, even a major or ancillary BSc level, so we from Association of Chemistry Teachers, we have an association which conducts every year a test called concept test in chemistry, contact. So that exam also very useful. This will clear with many of your improve your this one, then I would request faculty members to really take care or allow to take the food. Then next slide, and we also conduct this RJs of RJ Raman Science Foundation every year we conduct this one on September also, and also very important is science reading. Okay, many times even we now we don't read for even exams. We want to only see from this one, and so resonance and chemistry and engineering news. So resonance should be it's a very undergraduate science magazine. Many concepts explained thoroughly from the first issue I have been using it. I have been reading it. Then chemistry and engineering news, chemistry world published by ACS, and this is published by So it's very important. These things makes you competent in chemistry. Gaining a competency is very important. So remember that your family members, well-wishers, friends, all of you believe that you bring fortune to your family by studying. So it is your responsibility to really achieve this one. So the capacity to learn is a gift, and the ability to learn a skill, and the willingness to learn is a choice. So you think that success is like I study, it will go like this. No, actually it will be like this only. It will be so messy. It's going to be like that. So be prepared. So I will leave this idea. I always consider that I am work in progress. Thank you.
Thank you, sir, for the nice presentation. Not only about his own research work, but also what is good for you as students, for your future, the different avenues, for your further studies as well as job opportunities. Very enlightening talk. So I would like to thank you, sir. For lack of time, we have one or two questions from scratch to the top. So you learn from the example, and you are the example for us. Thank you, sir, for the nice presentation.
Thank you very much.
Dear participants, now we will
Hello, good morning, sir.
Sir, good morning, sir. Good morning, sir.
Hello.
Sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Now, sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Now, sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Now, sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Now, sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Now, sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Now, sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Now, sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Now, sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Now, sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Now, sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Now, sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just few more minutes.
Okay.
Few more minutes. Sir, good morning, sir. Good morning, sir.
Hello.
Sit upon, Professor. Just a minute, Professor.
Hello, good morning, sir.
Sorry. Just
Two more minutes. Okay, okay. Sir, good morning, sir. Good morning, sir. Silakan diulang terus. Good morning, sir. Sari, satu. Two more minutes. Okay, okay. Sir, good morning, sir. Good morning, sir. Silakan diulang terus. Good morning, sir. Sari, satu. Two more minutes. Okay, okay. Sir, good morning, sir. Good morning, sir. Silakan diulang terus. Good morning, sir. Sari, satu. Two more minutes. Okay, okay. Sir, good morning, sir. Good morning, sir. Silakan diulang terus. Good morning, sir. Sari, satu. Two more minutes. Okay, okay. Sir, good morning, sir. Good morning, sir. Silakan diulang terus. Good morning, sir. Sari, satu. Two more minutes. Okay, okay. Sir, good morning, sir. Good morning, sir. Silakan diulang terus. Good morning, sir. Sari, satu. Two more minutes. Okay, okay. Sir, good morning, sir. Good morning, sir. Silakan diulang terus. Good morning, sir. Sari, satu. Two more minutes. Okay, okay. Sir, good morning, sir. Good morning, sir. Silakan diulang terus. Good morning, sir. Sari, satu. Two more minutes. Okay, okay. Sir, good morning, sir. Good morning, sir. Silakan diulang terus. Good morning, sir. Sari, satu. Two more minutes. Okay, okay. Sir, good morning, sir. Good morning, sir. Silakan diulang terus. Good morning, sir. Sari, satu. Two more minutes. Okay, okay. Sir, good morning, sir. Good morning, sir. Good morning, sir. Silakan diulang terus. Good morning, sir. Sari, satu. Two more minutes. Okay, okay.
Sir, Chittapon.
Good morning, sir. Good morning, sir. Good morning, sir. Silakan diulang terus.
can proceed.
Okay. Wait a moment. You enter
proceed.
screen. Maybe this one. Okay. Wait a moment. Okay, now it's the full screen. It is full screen now. Maybe
Off
this one.
screen only. You can
Okay.
proceed, professor. Is it
Wait a
visible?
moment.
Visible. Full screen.
Okay, now it's the full
Okay.
screen. It is full screen now. Maybe
Off
this one.
screen only. You can
Okay.
proceed, professor. Is it
Wait a
visible?
moment.
Visible. Full screen.
Okay, now it's the full
Okay.
screen. It is full screen now. Maybe
Off
this one.
screen only.
Maybe
You can
this.
proceed,
Okay.
professor. Is
Wait
it
a
visible?
moment.
Visible. Full screen.
Okay, now it's the full screen. It is full screen now. Maybe
Off
this one.
screen only.
Maybe
You can
this.
proceed,
Okay.
professor. Is
Wait
it
a
visible?
moment.
Visible.
Okay.
Full screen.
Okay,
You
now
can
it's
proceed,
on full
professor.
screen.
Yes,
It's
yes.
full screen now. Maybe this
Thank
one.
you very much
for your kind introduction.
You can
Okay,
proceed,
right.
professor. Is it visible?
And okay, my name is
Okay,
Okay, now
you can
it's
proceed,
on full
professor.
screen.
Yes, yes.
It's full screen now.
So today I would like to
Thank you very much for your kind
show you
introduction.
about
You can
Okay,
proceed,
right.
professor. Is it visible?
And okay, my name is
Okay,
Okay,
you
now
can
it's
proceed,
on full
professor.
screen.
Yes,
It's
yes.
full screen
So
now.
today I would like to
Thank you very much for your kind
show you
introduction.
about
You can
Okay,
proceed,
right.
professor. Is it visible?
And okay, my name is
First,
Okay, now
you can
it's on full
proceed.
screen.
Yes,
It's full screen
so
now.
today I would like to
Thank you very much for your kind
show you
introduction.
about
You can
Okay,
proceed,
right.
professor. Is it visible?
Okay, my name is
First,
Okay, now
you can
it's on full
proceed.
screen.
Yes,
It's full screen
so
now.
today I would like to
Thank you very much for your kind
show you
introduction.
about
you can
Okay,
proceed,
right.
professor. Is it visible?
Okay, my name is
First,
Okay, now
you can
it's on full
proceed.
screen.
Yes,
It's full screen
so
now.
today I would like to
Thank you very much for your kind
show you
introduction.
about
you can
Okay,
proceed,
right.
professor. Is it visible?
radical can decompose some organic product in wastewater. And also, electron in the conduction band radical also can produce hydrogen by react with the proton in water. And also, this is a electron of the photocatalysis in the conduction band. Normally, the IO2 is a common photocatalyst that water. And also, in the electron application in the conduction band. Normally, the IO2 is a common because if electron recombine with the also in the electron cannot have the conduction band. Normally, the IO2 is a common because if electron recombine with the also in the electron some method need to normally develop because if electron of the electron for example, so some method can use normally elimination of the electron hole pair and also improve the light absorbability under visible light irradiation. Of the so let me introduce you about the graphitic carbon nitride. Graphitic carbon nitride or GCTN4 has a layer structure. So let me introduce you about the graphitic carbon nitride. Present interacting and graphitic carbon nitride or GCTN4 due to the has a layer structure. So let me introduce you about the graphic carbon nitride. So recently, prototype activity for the due to the has a layer structure. So let me introduce you about for the evolution. So recently, and also for the degradation of the molecule in US water. So the advantages of the graphitic carbon monoxide is about
Professor, sorry.
degradation of
Professor, sorry.
the molecule in
Once
US
again, you got to
water.
present
So the advantages of the graphitic carbon monoxide is about
Professor, sorry.
degradation of
Professor,
the
sorry.
molecule in
Once
US
again,
water. And this result we call energy resource distribution of the tap or EIDT pattern. So it's clear. You can see the graphite carbon nitride. This is how we call energy resource distribution of the conduction band bottom around 2.7. So it's clear. You can see the graphite carbon nitride. This is how we introduce energy resource distribution. We can have the band bottom around 2.7. So it's clear. You can see the graphite carbon here. This is how we introduce energy resource distribution. We also have the lower band bottom around 2.7. So it's clear. You can see the graphite carbon here. This is how we introduce energy resource distribution. We have the lower difference around 0.7. So it's clear. You can see the carbon here. This is how we introduce energy resource distribution. We have the lower difference around 0.7. So it's clear. You can see the carbon here. This is how we introduce energy resource distribution. We have the lower difference around 0.7. So it's clear. You can see the carbon here. This is how we introduce energy resource distribution. We have the lower difference around 0.7. So it's clear. You can see this is how we introduce energy resource distribution. irradiation. So also we modify the oxygen also irradiation. Oxygen by the dope sample. Because also we modify you can see the surface structure of the modified sample by the dope sample surface compared with also we modify you can see the surface structure when we introduce some of the modified sample by the dope sample surface it's gonna help with the development of carbonization of the carbon sheet when that's why we observe the modified sample by the dope surface it's gonna help with the development of carbonization of the carbon sheet and the roughness surface of the therapeutic carbonization of CN sample can provide higher specific roughness surface of therapeutic carbonization of CN sample and can provide higher we observe the roughness surface the morphology of the therapeutic carbonization and can provide higher we observe the roughness surface the morphology for the this being normal therapeutic carbonization we can observe morphology when we use the of the for example in this case we use we can observe some like when we use the humidity because graphitic carbon nitride, suggesting that CN1, which is optimized sample, graphitic carbon might have low risk, suggesting that recombination of the ethanol pair compared with the pristine one, because of the generation of might have lowest suggesting that trap state between the valence band and the conduction pair. Compared also for the current density and might have lowest suggesting that trap state and can be seen that the optimized sample also show the higher current density might have lowest smaller impedance can be seen that the optimized sample also show the higher current density suggesting that might have the OCN1 impedance produce more electron show the higher current density suggesting that have also, we check the decayed byproduct and we detect some like several. Also, we check the of the derivative decayed byproduct and we detect some. Also, we check the toxicity by using E. coli test, and in this work was done by Dr. Also, Yanisa. We check the toxicity actually by using she is my E. coli test, and in this work was done by Dr. Yanisa. She performed like actually by using E. coli under my E. coli test, CIP solution, this work was done by CIP solution. Also, she performed that actually by using E. coli solution, we cannot see E. coli solution and CIP solution. Also, she because that actually solution, but after we cannot see composition of the CIP by using because the graphitic carbon nitride has positive and negative charge here. So the positive charge of the sepiolite can absorb the palladium ion here and reduce it on the surface of the graphitic carbon nitride. And this slide show you about the UV result and the optical band gap. And it's clear that the composite sample show higher visible resolution ability compared with a pristine graphite carbon nitride, and because of the complete sample have the junction between the complete sample have the interaction between the graphite carbon nitride and the sepiolite, and the interfacial junction can generate the interfacial trap state between the junction, so it can reduce the energy band gap. Also, if we introduce some palladium into the sample, we can further improve the reliability here. And you can see here, we can also reduce the energy band gap by introduction of the palladium nanoparticle. And for the reverse double beam photoelectric spectroscopy result, we can see the new trap state. Even just like we mix the sepiolite and the graphite carbon nitride, we observe the increasing of the trap state around here and here. So the new trap state might be come from the interfacial contract between graphite carbon nitride and the sepiolite. So this new trap state can trap the electron, and this trap state can avoid the recombination, and it can be proved is what proved by the photoluminescence result of this sample, the black one here. And after we introduce the palladium, the trap state reduced a lot. So this the decreasing of the new trap state suggests the transfer of the electron from the new trap state of the graphite carbon nitride and in the interfacial trap state. These electrons can move to palladium nanoparticles, and it can avoid the recombination of the electron hole pair in the graphite carbon nitride. And this optimized sample show lowered PR intensity compared with the pristine graphite carbon nitride and the composite without palladium. And here show the photocatalytic mechanism for the system. So you can see the electron can move to the interfacial contract between sepiolite and the palladium here to avoid the recombination of the electron hole pair in the graphite carbon nitride. So the lower recombination of the charge carrier can improve the CAP degradation under visible light irradiation here. And just not only natural clay that we use, we also try to use steel slag, because in the steel making process, produce a lot of the slag, for example, but furnace slag and converter slag here. So especially for the converter slag, you can see in the composition, the converter slag contains some amount of the iron oxide. So this compound might can act as a photocatalyst. So it has some potential to use a converter slag to make composite with some main photocatalysts, for example, graphite carbon nitride. So in this work, we try to use artificial converter slag for making the composite with the graphite carbon nitride, and apply this one for the degradation of the imidacloprid under light irradiation. So generally, we synthesize the artificial converter slag by using this chemical. We simplify this artificial converter slag by using this 4 chemical and calcite at this temperature. And then we try to grow the graphite carbon nitride in the presence of the converter slag as shown in here. And the results show that we can make around 1% to 5% of the slag in the composite as shown here. And then we catalyze by this several technique and apply for the imidacloprid degradation. So for the photoluminescence, you can see the optimized sample, the green one here, which contain around 4% of the converter slag, show the lower PR intensity, indicating that the heterojunction between the graphite carbon nitride and converter slag can inhibit the recombination of the electron hole pair of the graphite carbon nitride. So we expect this sample might show better photocatalytic performance for the imidacloprid degradation. And We also observe the morphologies of the synthesized sample by using SEM analysis. And for the graphitic carbon nitride, you can see some small particles of the graphitic carbon nitride here, like a small pet-like structure. But the composite slag show like a larger particles compared with graphitic carbon nitride. And in the composite, the small particle of the graphitic carbon nitride can be observed on the big size of particle of the steel slag. So these results indicate the steel slag can act as a template or support material to grow the graphitic carbon nitride, and this one can avoid the accumulation of the graphitic carbon nitride particles to enhance more active surface, improve more active surface for the photocatalytic reaction. And also, we use RDP pass technique to obtain the ERDT pattern. And it's very interesting because in the composite sample, the big peak of the graphitic carbon nitride here disappear after make the junction between the graphitic carbon nitride and the slag, which has iron oxide in the steel slag. So this result suggests about the transfer of the electron from the graphitic carbon from the iron oxide in the steel slag to the graphitic carbon nitride. So this one can prove the direction from the steel slag to the graphitic carbon nitride. And also we check the imidacloprid degradation, and it's clear that the composite sample show lower higher degradation activity for compared with the pristine graphitic carbon nitride here, especially for the 4% of the steel slag in the sample, indicating that the optimize of the steel slag in the sample can enhance the photocatalytic degradation of imidacloprid underlying irradiation. And the superoxide radical is the main active species for this system. So here show the photocatalytic mechanism. So as I mentioned, from ERT pattern suggest us about the direction of the electron transfer, right? So the electron from the steel slag can transfer to the valence band of the graphitic carbon nitride, and we can keep the electron in the conduction band of the graphitic carbon nitride for production of the hydroxyl superoxide radical, and hydroxyl radical can be produced on the side of the steel slag here. So both radical can decompose imidacloprid to the degraded byproduct. And next work, we try to use steel slag also. We try to produce the hydroxyapatite by using steel slag. Normally the hydroxyapatite has a large energy band gap, as you can see here. Around the energy band gap of the hydroxyapatite is around 6 eV, so it's impossible to use as a photocatalyst under light irradiation, right? But if we introduce some iron into the structure of the hydroxyapatite, as shown here, you can reduce the energy band gap from 6 point something to around 3.0 eV. So this material might have some activity as a photocatalyst for some reaction. So in this work, we use artificial butt furnace slag with as a precursor for the hydroxyapatite, and you can see after we use the artificial butt furnace slag and synthesize by using hydrothermal method, we use the iron nitrate to make substitution between calcium in the structure of hydroxyapatite and iron to make iron doped hydroxyapatite, and the XRD results show the successfully formation of the hydroxyapatite after hydrothermal, and it has no the impurity fate of iron oxide after ionic exchange between iron and calcium. And the SEM image confirm the if we use a calcium oxide, the calcium oxide can transfer to the hydroxyapatite, like I'm showing here, right? But if we use butt furnace slag, also some part in the butt furnace slag cannot transformed to the hydroxyapatite. But for example, some like aluminum or silicon, so it can act as a template to grow the hydroxyapatite on the surface of the aluminosilicate, as I mentioned here. So the utilization of the butt furnace slag is not just only source of the hydroxyapatite, but the aluminosilicate in the butt furnace slag can act as a template to avoid the accumulation of the hydroxyapatite particle. And here show the EIDT patterns of all sample, and you can see from the hydroxyapatite, it almost has no electron tap density because of it has very large energy band gap, right, around 5 or 6 eV. But when we introduce iron by varying the concentration of iron from low concentration to the high concentration, we can observe the new trap state around 3.0 electron volt. So this new trap state might be come from iron in the structure of the hydroxyapatite, and is what confirmed by the DFT calculation that I show you in the previous slide. And also, if we use the butt furnace slag, the butt furnace slag also show new tap state around here also, but it also have some lower tap state around 2.4 eV here. So the utilization of the butt furnace slag might be better compared with the calcium oxide, because we can produce a lower tap density around 2.4 eV. So this one can receive the visible light compared with the sample from the calcium oxide. And we apply this material for hydrogen production, and it can be seen that the iron doped hydroxyapatite from the butt furnace slag, the orange one, show the higher hydrogen production evolution activity compared with the pristine hydroxyapatite and iron apatite from the calcium oxide. And also, we use this material for the chromium reduction, and also the base sample from the hydroxyapatite from the butt furnace slag show better chromium reduction activity compared with the other samples. So this is how indicate that the source of the butt furnace slag as a source of the calcium, which contains some aluminosilicate, can enhance photocatalytic activity for the hydrogen production and the chromium reduction by generation lower electron tap density around 2.4 eV, as I mentioned here in the EIDT pattern. So thank you very much for your kind attention.
Nice presentation, excellent information, Professor. You have started with the starting photocatalytic the composites, and the main focuses on ciprofloxacin antibiotic, what way it is conducted, and photoacoustic spectroscopy, and CPO light degradation on the CIP, ciprofloxacin, in detail, exactly what way it is used, and the sales slag mainly focuses on graphite carbon nitride. So major composite, which is very important in your research. Mostly it is covered in your talk, and efficiency, and the PFS also. And finally, we will talk on photocatalytic hydrogen evolution. So photocatalytic hydrogen evolution nowadays it's important in the energy aspect. So
Yes.
highly informative, resourceful talk, Professor. Now over to any queries from the audience. Now the audience, you can you ask question. Professor will answer these questions.
Hi, okay.
Audience, you can avail this opportunity.
Any question?
Ah,
Okay.
Professor, one of the
Okay.
through text asked the question.
Okay.
Can you read this?
Okay. So I got the
Resolve
question.
spectra is essential for all kinds of photocatalytic reaction. The question. Can you read, Professor?
Yes, yes. Yeah, this question from Mutupabu about resolved spectrum is essential for all kind of photocatalytic reaction. Yeah, actually, I guess you mean the EDT result, right? Resolve reversible beam spectroscopy spectrum. I'm not sure. This which spectrum? Resolve spectrum. Resolve spectrum.
Resolve
Yeah,
spectra. Ah, yes.
yeah, it's important because that one, the ELT pattern, we call ELT pattern. So this pattern can suggest you about the electron trap state in the semiconductor. So sometimes it has a relationship between the electron density with the photocatalytic application activity. If you have more electron trap density, you might have higher photocatalytic activity in some cases. Yeah. Yes. I'm not sure I answer your question because I'm not sure about the resolved spectra.
Any other questions? You can text the questions so that professor will answer. Any other audience? You can text.
So very good morning, sir.
Good morning.
So thank you for your nice presentation, sir. So I have a doubt. So is it possible to carry out photocatalytic degradation in solid state instead of solution state?
Actually, actually, yeah, it's good question because you want to decompose some like gas phase, gas
Solid state, sir. Solid state.
solid state. Might be possible maybe possible.
In solution state, there is a problem in solubility problem, sir.
Yes.
Like,
Because actually mainly I use this material for the water treatment, but sometimes we can apply the photocases for the gas proton treatment. For example, we can eliminate the nitrogen oxides like that. So yeah, I think it's also possible to use it and in the solid state system.
Professor, that is the efficiency of the photocatalytic activity of graphite carbonate depend upon which one, Professor?
Pardon, could you say again? I can't hear. Sorry.
Efficiency of a graphite carbon nitride depend upon which one? Depend upon which are the factors involving efficiency of the graphite carbon nitride?
For the carbon nitride, you mean?
Yes, Professor.
Yeah, actually, I think the graphite carbon is a good material recently, but yeah, we need to modify the graphite carbon nitride because it has a high recombination rate as I mentioned. Yeah. So one more thing that we can do is about make the heterojunction with the other semiconductor, and also we can do the energy band gap engineering to reduce the energy band gap of the graphite carbon nitride. Yeah, so we can improve more photocatalytic efficiency.
Another on the textile question, Professor. In general, slag has a lot of impurities who is more responsible for degradation along with Cyprian?
Yeah, that's a good question. In the steel slag, mainly contain some silicon, aluminum, and iron oxide. Yeah, so I think the main component in the slag that contribute for response for the photosynthetic activity is should be iron oxide. Should be iron oxide.
Professor, what is photoacoustic spectroscopy? What is the use?
Ah,
Photoacoustic.
for the photoacoustic spectroscopy or RDB pass, uh, actually this technique, now first the Professor Otani in Hokkaido University developed the technique for detect the metal oxide fingerprints. Like we can use this technique as a fingerprint to classify the TiO2. Even it has same phase, but it might show a difference, the pattern, because different electronic structure on the surface of the TiO2. And also we apply this technique, photoacoustic spectroscopy or RDB pass for detection of the neutral state. And we try to link this knowledge to the photocatalytic efficiency, because after for example, like if we introduce some gas element into the main structure, for example I introduce some iron into the hexapatite, we can see the neutral state from the iron by using the RDB pass technique. So this one can confirm the generation of the neutral state. Yeah, and also when we have the composite between the materials, sometimes we observe some interfacial heterojunction between two materials. So this interfacial junction might can trap the electron, and it can avoid the recombination of the electron hole pair.
Very nice. Very nice. Thank you very much, Professor.
Right.
Any other question, audience? So no more question. I think reach the audience, and in spite of your busy schedule, for more than 30 minutes you have waited. You was in the on time, but due to the first session late, so we will start in the 12 o'clock only. So this is the audience, your audience, Professor. All the higher institution, universities, in our students and other college faculty members. Uh, um, Therefore, that is a 80 paper abstract have been received. Out of it, 40 more than 40 paper presentation, and remaining poster presentation. Very good response because of the highly resourceful resource persons. So such a wonderful, nice person. In spite of your other work, you have been supported as you have been presented on time. So thank you very much. Behalf of college, behalf of faculty member, thank you very much, Professor. Keep
You.
on touch. Thank you.
Thank you very much. Thank you.
Thank you. Thank you. Thank you. Now after this session over.
Thank you very much, everyone.
Thank you.
For
Thank you.
your attention.
has received many honors and awards, of which, to mention a few, Junior Research Fellowship from DST, and SR, the Senior Research Fellowship from DST, and he has got Japanese Government Fellowship next for 2 years, and he was there in Toyota, Japan, and he also worked as assistant professor in Konkuk University, Seoul, South Korea, and he was formerly assistant professor in and senior. Right now, sir is associate professor in Japanese government. Also, he is head of the technical science department there in Toyota of the School of Technology. He worked as assistant professor in Central University, Seoul, South Korea. He has published formerly as professor in technology. Right now, sir is associate professor in Japanese government. Also, he is head research in random School of Technology. So right now he's a associate professor. He has published formerly as professor in technology. Right now, sir is organic light emitting diodes and novel organic injection layers. We are very happy to welcome you, sir, for this international conference on expanding frontiers in chemistry, EFC 23. Now I hand over the session to Dr. K. Siddharam. Thank you, sir.
Good afternoon, Anandar. So thank you for the nice introduction, madam. Thank you. So I really thank the organizer for inviting me to lead this wonderful lecture. So today we are going to see, because the title is reflecting that organic living. Generally, I think everybody is sure nowadays what is organic living. Only I don't know that what is oil. OLED, what is OLED? And that we are using our OLEDs nowadays. We are installing it and we are using it. Don't install it. So nowadays, everybody is having a mobile. Everybody is having a mobile phone. So mobile phone displays. Or mobile phone displays. Nowadays, the organic electricity displays. So that in Samsung advertisement, they used to put AMOLED. AMOLED. And nowadays know that AMOLED actually matters. It's a very good interdisciplinary. So interdisciplinary subject that so what is the role of chemist, what is the role of physicist, what is the role of engineer? So all three play a very important role. Organic chemistry used to synthesize the number of molecules so that related to the semiconducting molecule or the luminescent or phosphorescent molecules or the insulating molecules. And then this is generally used to design and structure device and fabricate the structure and finding out its efficiency, how it is good for commercial applications. In the end, then just transfer it into the that's the reason that we generally organic devices, electronic devices, then it is introduce the mechanism. So all three people's roles are very important here. So today we are going to see some of the fundamentals because it may be very interesting for our people also. Almost all students, all audience are from chemistry. So we understand really from device point of view also, it's an interesting one. So it already I told you that organic electronics is a multidisciplinary science and technology related to class of organic material. Without organic material, then there is no organic electronics. So organic is used to synthesize a lot of organic molecules. So that's why that we are having organic electronics devices. So also material, what type of materials? Both the single molecule as well as the molecules. So that why people are interested to go for organic electronics? Then because of ultra low cost, lightweight, as well as the flexible electronic devices for display. I hope that nowadays you may see the televisions in shops. If you want to buy a television, then nowadays all the televisions are OLED TVs, organic light everything televisions. So in future, when we get very cheap displays for the OLED devices for display, we will see how these. The importance of organic electronics almost unlimited televisions. Nowadays, all the televisions are OLED. Of course, you know it very well because since people are chemistry background, then again it is used to tailor the molecules. Tailor means that they used to cut and then attach the molecule. So with respect to the applications. So that organic electronics is never replacing traditional silicon-based or traditional inorganic-based electronic devices. Organic electronics is only useful for low-power electronic applications. That's why people are using it for these days. So organic semiconductor, some of the important, some fundamentals I used to give here. So organic semiconductor again is based on an organic molecular component. Organic means everybody is told that it is composed of nitrogen and carbon and oxygen. So that like inorganic semiconductors are not like that. Semiconductor means you know it very well. You know studied even chemistry people also study what is the conductor, what is insulator, what is the semiconductor. Based on that semiconductor property. So here inorganic semiconductor generally are crystalline with the band-like charge. Generally little exists here. So the band-like charge transfer inorganic semiconductor. But organic semiconductors are not like a crystalline material. It is an amorphous as well as small crystalline in which charge transport occurs. So moving of the charge carrier between the five molecules. Moving means jumping of the electrons from one molecule to the other molecule. That's called a moving process. So if your system is a pi-electron system, it is very easy to move the electrons from one place to the other place. That is the reason organic molecules are highly used for low-power electronic applications. It is a standard one. I don't want to explain here. So simple molecule, small molecule, you know it very well. As what is the small molecule really? So how the body conjugated systems are. So for example, I put this one because for very I always used to give this talk for physics people, physics students. But now today is chemistry, so that it is very easy to understand what is the small molecule, and the next is long chain molecules. So long chain molecules with the bilateral system. So it's very easy to so move an electron from jumping of the electron from one molecule to the other molecules. How the people generally used to determine what is the bandgap then they used to say that gap between the low and the low highest occupied molecular orbital and lowest occupied molecular orbital. So for a bandgap of organic molecules, they used to say this. Next. So these are some of the organic semiconductors. Semiconductors, fantastic small molecule. Fantasy everybody knows that by being attached together forming a molecule is called a fantasy. And another is the thalosphene. Both are small molecule organic semiconductors. Traditionally, I mean, a lot of reports are available for these two materials. Small molecule materials. Example, fantastic small molecule material. Fantasy organic semiconductors for polymers like poly3XL. Another polymer. I put it over there. I think it will. So, about all the molecules are acted as organic semiconductor. Organic semiconductor. Small molecule as well as the molecules. Next. Organic, what is the difference between organic semiconductors and inorganic semiconductors? A lot of difference between organic semiconductors and inorganic. So, organic means then definitely everybody knows that molecular property is very important. Molecular property. Organic means the molecules. So molecular property is playing very important role. But not in inorganic semiconductor, crystalline property playing a very important role. And I told you another. I told you earlier that hoping type of charge transfer. So hoping means like jumping of the charge carrier from one molecule to the other molecule. And generally, bandwidth charge transport is very strong. Like running a student from here to there. So it's very fast. So that you can reach that place very fast way. But hoping is not like that. Hoping is jumping from here to there, then always you can reach that place little late compared to that of running. So it's a very big difference between organic semiconductor material and inorganic. That is the reason inorganic semiconductor materials are having a very high mobility and it is used for high power electronic applications compared with organic materials always having very low mobility, so that the low power electronic application. That's why we are using organic semiconductor material. Next. These are some of the important development in organic electronic that I took it from the official model websites, so that three people playing a very important role. Because even everybody knows that polymers are used as a very good insulating material. Still, people are using the polymers. Why are they cover up polymer or plastic polymers? Because no one is known that polymers are conducting agent. So that then these three people, Shiragawa and then Mental. Put the next. So this is the first report. They reported in the year 1977. So that see the poly as clean is the polymer. So halogenation. Halogenation means the grouping of halogens in the poly is clean. So that they see that the conductivity is about the 10 to the power of minus 9 Siemens per centimeter. Conductivity. So before halogenation. But after halogenation, you see the conductivity is about 38 Siemens per centimeter. How much order? Almost 10 orders of magnitude change in conductivity. So it was the first report in Journal of Chemical Society in 1977. So whether the polymers also in conducting nature. Conducting nature means conducting electrons. So that after this tremendous invention, so that a lot of development in organic electronic devices based on the different types of molecules. So that for this tremendous invention of conducting polymer, three people awarded the Nobel Prize in the year 2000 in chemistry. Professor Alan Keegan from University of California and Professor Hideki Shiragawa and Mental University of Pennsylvania. So for the tremendous contributions to the development of organic conducting polymers. So that they are the basic pillars of the development of organic electronic materials and devices. So they invented a lot of polymers for the connecting polymers for the different electronic applications. Organic material, organic semiconductor, not only used in organic light indicators, it is also used in fabrication of organic transistors and organic solar cells. Organic solar cells, nowadays organic sensors, even radio frequency identification tags. So library tags you are having nowadays. Earlier, when it was used to fabricate by inorganic material, traditional material, then cost is expensive. But nowadays, people simply using organic based radio frequency identification. Less, cost wise very less and then very easy. Of course, so that all the electronic devices fabricated based on that organic materials are biodegradable. Very important part here. So inorganic based material not very biodegradable. Organic materials are used generally biodegradable. That is a very important plus compared with the inorganic material. So after this invention, these are some of the applications I put over here that for organic field transistors. It is highly useful for making sensors and displays. Organic latent detectors. We will see in detail about what is OLED and then radio frequency identification tags, solar cells, organic solar cells, organic memory devices, and OLED based sensors. I told you that these are all some of the applications of the organic semiconductors. So methods of preparation of organic layers. Generally, small molecules. I told you the small molecule organic polymers. Polymers are very easily dissolvable in organic solvents. Very small molecules are not dissolvable in these. How to prepare a thin film of them? Very simple, number of ways are there. If your material is not dissolvable in solvents, then generally this method is used to prepare a thin layer of your material. This is evaporation technique. So here, this is the big chamber, and then this chamber is completely evaporated under vacuum condition. So that your material is put over here, and then this is the organic material, and then if you heat it, and under high vacuum, then the organic materials have started to evaporate, and then very good thin layer of material is formed at this substrate. If your material is not dissolvable, also your material is having a very good evaporation property, a very good evaporating property under high vacuum. This is one of the methods to prepare an organic thin layer. This is highly useful for fabrication of organic materials. And it's spin coating. And all polymers are, I told you that it is dissolvable in organic solvents. Organic solvents, once it is dissolvable in organic solvent, you can make a solution. So spin coating, so put a substrate on the spin coater, drop of the solution. Once you started to spin that substrate, automatically a thin layer. This is step 1, step 2. So once during the rotation and after rotation, then forming a thin layer of your material. So organic thin layer formation by this spin coating technique. This is one of the simplest technique. Don't need a sophisticated instrument. That instrument cost itself 20,000 to 80,000, maybe 1 lakh. Is enough to prepare a thin layer of your any type of any type is dissolvable in solvents material. That type of those materials dissolvable in solvents, you can prepare it by simple laser spin coating technique. And next, this is inkjet print technique. What is inkjet print? So you are having inkjet printer. Inkjet printer nowadays people are using a laser. Inkjet printer also using. So inkjet printer. Like a dropper, inkjet dropper. If you are able to make ink of your semiconducting material, ink of your luminescent material, you can use those inks to prepare this printed device. This is a printed device. You see the number of transistors that yellow colors electrodes, gold electrodes. All these are gold electrodes using an inkjet printer. It is like an inkjet is deposited on the surface of the The process of that beautifully forming that device, their device. So you will increase. So your increase playing a very important. This is the end of how it is like a printer, printing a NJ printer, printing letters. Like a letters, it is just printing the ink on the surface of the device, then forming it. You see the number of transistors. A small flexible structure. You see the number of transistors. So more than 100, more than 200, more than 300. And time duration to the printing of the final ink on the surface of the electrode is very less. So it's like a paper. If you are getting a print, then automatically how much time it will take to come out of the paper. It's a matter of just a few seconds. In way that one can prepare the beautiful that organic devices like this. These are some of the organic transistors. This is the other method. Then this is a straight electrode. It's very protein. That is like and if you are getting a painting is straight, how much time it will take to time out even like a straight protein. It's just preparing one way that we can get the heat prepare the beauty semiconductor solution and using this technique is organic transistors. This is the layer of organic material. This is the straight that is like and so what we is straight how much time it will take to like a straight protein. It's not any preparing that we can get the heat prepare the beauty semiconductor solution and using this technique is organic transistors. So this is the layer of organic material. This is the straight and so what we is temperature is here tuned for the bacteria. So it's not any clear image. In the image, it looks like a blank. And so, but this is used to call, but UV nano problem is completely eliminated by the organic light emitting diodes. And high resolution, very high resolution displays. No other displays are available in market or even in future also. So high resolution displays are OLED displays and also fast switching time. So that's that we are enjoying in our switching time. So it's not like our old television. Once you switch on, then it takes more time to come out that friction. But once mobile phone is not like that. Once you push the button, automatically just a fraction of a second it started to display. Fast switching is also important. Important advantages over the other displays. Low voltage, low voltage is very important. Low voltage, that's why that you are using it in your mobile phone with lithium ion battery. Lithium ion batteries is more than enough to grow your mobile displays. If you need more energy in it, nobody is using those type of displays in the mobile phone. So it's very important advantages. So that thin film display I told you, these are some of the advantages, some of the histories of OLED, some of the people lack of time. So that first, this is the he is the first professor. First LED with small molecule organic light emitting diodes fabricated by Professor Argach, Professor Tang, CW Tang. So using ALQ3 molecule, this is a small molecule. So he's from product company in USA. First OLED displays that fabricated in the year 1987, and later first LED displays, organic based LED fabricated with the polymeric material, polymer displays by Professor Arul friend. So Canadian laboratory from Cambridge University. So these two contributed a lot to the development of the organic diodes. So that has been we are enjoying the displays technology beautifully. So this is the structure of the OLED. See the cathode, and then this is a anode. It's nothing very simple. So this is electron transport layer. This is a transport layer, emissive layer. From the cathode, electrons are injected. Cathode electrons are injected. From the anode, holes are injected. This emissive layer, holes and electrons both are recoupling together exciton formation. Exciton we may study. Exciton means that hole and the electron pair. Exciton formation is that this automatically light emission is taking place. Electrons and holes are combined together here in emissive layer. Light emission is taking place. This is the structure of OLED. Entire OLED you may fabricate it in glass substrate or any plastic substrate. Because here we don't need a higher temperature, processing temperature. So for fabricating this type of a device, we can fabricate this type of device at room temperature. That's why we will fabricate entire device in a plastic substrate, not in a very hard substrate. So plastic substrate, if you go for using plastic substrate, if you go for high temperature, then it will not resist. So automatically plastic will not go very high temperature. But to entire device, we can fabricate it in room temperature. You can use it in plastic substrate. So this is you can fabricate this structure either on glass or on substrate. It is possible. And then this is the traditional. This is the energy level diagram of a cathode. So this is the energy level diagram. So that this is the emissive layer cathode. Plutonium from the cathode. So electrons are injected. So electrons are jumped from here to here. Electron transport layer and then emissive layer. And holes from the anode, holes are just injected, holes are jumped to the emissive layer. At the emissive layer, exciton, electrons and hole formation is takes place. I told you that electrons and holes both are combined together, then light flow is taken. Light emission is taken. So that in this simple way, electrons are injected over here, holes are injected. So exciton, electrons and holes recombine in emissive layer, so that light emission is taken. This is the standard principle. So that for this, people are doing this is the energy level diagram. Okay, how it is jumping of the electrons over here, how it jumping of the holes over here, and then comparing the emissive layer. This is a general energy level structure. This is a small molecule polymer based OLED. Small molecule, I told you that small molecules are not dissolvable in solvents. So that we need to evaporate it. So by using a sophisticated instrument, multiple layer like this, like I am between anode and cathode, like 4 layers that we need to prepare by evaporation technique. All small molecules are, and we need to evaporate it by a physical thermal evaporation technique. Polymer, it is dissolvable in solvent. So that between anode and cathode, that one single layer is put over here. This is the polymer OLED. Polymer OLED, either small molecule OLED. The thing is important mechanism is holes and electrons need to recombine at one layer, emissive layer. Once it is properly recombined at the emissive layer, then light emission is increased. Otherwise, you will not get a proper light emission at the OLED. So these are the types of OLED. Very interesting one. I told you that passive matrix, active matrix OLED, PM OLED, IM OLED, transparent complementing full level white OLED. White OLED is nothing but the recombination of just preparing a 3-layer red, green, and blue emitting OLED, combining these 3 layers, and you will get a white OLED. So passive matrix OLED, you see here, this is our anode, and this is our cathode, strips of anode and cathode. So in between strips of anode and cathode, then we are preparing an organic layer. That strips intersection point. This is the cathode with this is the so the strips are they prepare like this point. Intersection point is acting as a pixel. Pixel means generally displays the pixels used to or say that the intersection point is act as a pixel here. So that particular cathode and the anode strip orientation is here, OLED. So light is emitted at the intersection. Then here the important point is which pixel need to turn on. That is very important with respect to our picture. So we use some kind of external circuitry so that these displays are not good for a large area application. So that people are using this type of matrix for a small scale applications. So large power consumption is required for this type of PMOLED. That's why our mobile phones are AMOLED, not the PMOLED. A mobile phone displays are AMOLED. This is AMOLED. So instead of using strips in PMOLED, AMOLED no strips. Single layer of anode, single layer of cathode. In between, organic molecule, organic materials are prepared. So that is the reason. So full layer of cathode and the anode, organic molecule. Here, thin film matrix on the top of the anode. So that thin film matrix, a thin film transistor matrix. So determine which pixel is which type of pixel is needed to turn on with respect to your picture. That's the reason AMOLED is very useful for large area applications, because your less power is consumed than PMOLED, transistor matrix for LED. So large area displays are nowadays available like this screen. Like this screen of OLED televisions that recently fabricated. So I will show you later. These are some comparison. I will skip this place. PPTs and foldable OLED. Showing the foldable OLED, complete OLED is the fabricated on this surface of the plastic substrate, like a foldable plastic substrate. So that's a foldable OLED. And top emitting means the anode and cathode. One electrodes are complete opaque electrode. One electrodes are transparent electrode means then automatically the top emission is takes place. That's why the top emitting OLED. So suppose two electrodes, we are using cathode and anode. Anode and cathode both are transparent electrode, then light is emitted in both directions. Suppose this is an anode cathode. So both the anode and cathodes are transparent. Light is emitted in both directions. This direction and then other direction. This is called a bidirectional OLED. This is the bidirectional light emission takes place in transparent OLED. So this is the operation. Very simple. You see that the operation here is energy level diagram. So what is this? These two are work function of metal. Anode cathode we are using work function of anode and work function of cathode. This is the energy level. Energy level means the homo level. Organic materials are having homo level. So this is a homo level here. Electrons are injected. This is the emissive layer. So injected electrons are moving towards the central point. The injected holes are moving towards the central point. At the center, what happens? Electrons and holes recombination. Electrons and holes are recombined together. So light emission is fixed. It's a very simple basic operation mode of OLED. So injection of charge carrier. So in this place, how we are injecting it? By using batteries. So once the battery is down, means the displays are not so good. You can go into it. So the batteries are injecting the electron as well as the holes. Injected electrons are transported towards to the center. Here, emissive layer, exciton formation. Exciton formation means formation of electron and hole pair. That's the exciton. Exciton is electron hole pair. So exciton formation of the emissive layer. So emission is takes place. Automatically emission is takes place. This is the basic operation principle of our organic light emitting diodes. When you are getting a high power efficiency. So you see here, one electrons are injected, one holes are injected. It is one holes and the electrons are reaching at the same time. So that what happens? Then the emission, recombination takes place. Beautifully, the emission takes place. Equal number of electrons and holes means 10 electrons are injected here, 10 holes are injected here. So 10 electrons and holes are reaching this place at the proper time. Then your efficiency of the OLED is very good. Suppose 100 electrons are injected here, 100 holes are injected here, but 100 electrons are reaching this place very fast, but these holes are reaching this place very slowly. So 100 electrons, 50 electrons reaching here, only 10 electrons are reaching here means 10 holes are reaching here means 10 holes are there, 10 electrons only recombine, then remaining electrons are wasted. So that the efficiency is not so good. So that equal number of electrons and holes reaching this place is very important. High transport rate at a low operating voltage. High transport rate means that electrons are reaching this place. The transport rate of the electrons is between the layers are very good means, and then low operating voltage is enough to then get a high power efficiency OLED. efficient charge recombination. I told you that efficient charge recombination. 100 electrons are injected, 100 volts are injected, but only 10 volts and 10 electrons only recombine together. Then light emission takes place. Another 90 electrons and 90 volts are wasted. Not a high efficiency OLED device, so that efficiency is not so good. Emission from excited states, carrier balance is difficult to manage for single organic. So carrier balance means at same time reaching the place is difficult by using a single layer concept. That is the reason people are using a multiple layer. Multiple layer is whole transport layer, Lewis layer, electron transport layer, etc. like that. So that what happens here, electrons are injected, holes are injected. So equal number of electrons or holes reaching over this place, so that efficient recombination is takes place. Higher efficiency you can achieve. Why is we are using one side more layer? Why we are using one side less? This side, for example, I told you that in top electrode we generally use 3 layers. In low electrode we generally use 1 layer between the chemistry layer. Holes are used to move very fast, but electrons are used to move very slow. So if holes are used to move very fast, so we need some hurdles. That's why we need some more layer we are added on this section. We are trying to reduce the speed of the holes by multiple layers. But in electron side, no layers are used. From the electrode, it's directly reaching the emissive layer. So what happens? So by this type of structure of the OLED, so carrier balance takes place. Carrier balance means equal number of electrons, equal number of holes are reaching at the center point. So that what happens then efficient electron efficient light emission is takes place here. So these are all some of the energy level diagrams, so that how that the work function of metal, the work function of metal matched with the room movements, and electrons are injected. Work function of metal matched with the room movements, holes are injected. So efficient recombination is takes place here. So light emission is takes place over here. So that these are some of the concepts. And I will skip because you see electron injection from metal to organic layer. So either thermionic emission or tunneling process. Maybe tunneling you may call it a tunneling to barrier. Even if you are studying it in quantum mechanics, tunnel the barrier electrons. So maybe that so tunnel the barrier concept or jumping of thermionic emission. So I will skip this one of the important things how the function of. So you see here, I told you that the electrons are injected, holes are injected here. You see this barrier. For gold, this barrier is very high, very difficult to jump. For aluminum, somehow okay, for catching it's good. That is the reason. You see the efficiency. How much electrons are injected over here? See, for gold is very less efficient. It is difficult to inject electrons from here to there. But aluminum is somehow very easy, efficiency now very good. The calcium is very good, so that's why the efficiency is very high. So this barrier is very important. You need to choose your electrode material for efficient organic light-emitting diode, also fabrication. And then these are all some of the architectures, different architectures. So I will so some of the efficient, effective device architecture approach. So that maybe for this device architecture, instead of using a big layer, you see, big layer, large thickness area, you are using a layer, small thickness layer, efficient layer, then your efficiency looks very good. Maybe I will. This is a very important concept, is low carrier injection rate. You see here, so instead of having steps, so instead of jumping over here, it's very difficult to climbing, so that without step is very difficult, but with the steps is very easy. So the without easy here, so without this is here we are using multiple layer. Not multiple layer, what happens? This is a barrier. So it's very difficult to go. very difficult to go and impose from here to there. So efficiency is very difficult. So, but instead of using this type of structure, you see the steps. So instead of jumping, the steps are there. This simply represents the energy level. These are all the blue level, these are all the blue. So these different varying energy level of material, if you boost it, and you see that here electrons are jumping easily and are reaching this space. And so holes are reaching this space very easily by jumping between the two layers. But here is very difficult. Jumping is very difficult to reaching this space. This is the low carrier injection barrier. This is a carrier injection barrier. They are trying to reduce it by using a multiple layer mask. These are some of the steps people are using. High carrier ability, this is the balance. This is another important. So we are used to the carrier different energy levels, material, different energy level layers here. So electrons are injected, you see the electrons are going there. So not reaching this space and then moving to other side of the electrode. The same way holes are injected. Holes are not only reaching this space, it's moving other side of the electrode very easily. So due to avoiding of this effective carrier confinement. Confinement means that a combination of the charge carrier at this place. So that you see that they are changing this material energy levels. Different energy level material they are used. You see that large energy level material. So instead of using like this, energy levels are they increased as far as energy levels of the material near to initial layer they increase. So that what happens, injected electrons are confined here, injected holes are confined here. So that automatically electrons are recombined. Effective way to carry confinement is takes place in this type of structure. So that people are using effectively modifying the layers with a different homo and low energy levels like this. So this is instead of using a single layer. Instead of using a single layer, two types of invisible layer means invisible means that combination zone if you are in these means then automatically instead of using single layer, two types of layer adhesive layers means the recombination zone is increased so that effective recombination is takes place so that efficient OLED you can fabricate. This is another step. The multiple layer they have prepared it. So you see that 6 volt they put here, there 3 volt. 6 volt means that it is when voltage is required to turn on the device. Turn on means close your OLED, but it is reduced to that how much 3 volt here. So turn on voltage is reduced to 3 volt by using a PIL concept. PIL is undoped electron transport, undoped transport, but they are used to doped electron transport, doped proton transport on the invisible layer. They reduce the turn on voltage. Turn on voltage means voltage required to turn on your displays. So that our requirement is less voltage than turn on your display is very good for different applications, energy applications, different display applications. This is a tandem structure. Tandem structure means multiple structure. This is a multiple layer you need to prepare. And so that the structure is difficult, multiple layer, and we need to prepare and control the layer is also very difficult, but the efficiency is very good. So you can achieve the 100% of internal quantum efficiency by using this type of device structure. But structure preparation is difficult. Applications of OLED, what is very well about cell phone displays. Nowadays, all cell phone displays are OLED displays and OLED televisions and OLED lamp. The white OLED is going to then replace the lighting system in future. White OLED means very less power required to glow your white OLED lighting displays. So that people not only GE is working, GE believes in working for the preparation of white OLED displays, white lights, white lighting. So now it will completely replacing the and definitely future replacing all the lighting system available now. The very less voltage is required to then turn on your white lighting even used in house applications, even in industrial application. So this is, you see that transparent window lighting. What is transparent window lighting? So your entire organic molecule, entire OLED is prepared on the LED substrate. Entire material looks like a transparent. It looks like a transparent window. But it is, you see here, this is a transparent window, transparent glass. But it is not a transparent glass, it is a OLED. Once you turn on that light, then it started to glow like this. So that transparent window lighting. Once you turn off the light, then it automatically converted it like a ordinary window glass. So that all layers, all electrodes, all materials are white, transparent material, transparent OLED. Once you put it in, then you can use it like a transparent window lighting system. So one of the screen companies working in this area, and they are providing some of the beautiful product in the transparent window lighting system. AM OLED, I told you AM and OLED in a small screen, and I told you that the white light is going to replace all the lighting system. 3D displays. 3D displays are possible in fusion by organic lighting techniques. And e-papers. E-papers means that looks like our mobile, like a paper. No need to go change the paper every day. No need to get the paper every day. It is e-paper means so timely. Every hour that what happened, the time uses and papers are changing. So that e-papers are very famous. But maybe in future you will get a e-papers. Just completely entire display. This is a OLED display on plastic flexible sheets. So that e-papers are possible. Not no need to get everyday paper. Once you get e-paper, every day you can get using for these e-papers. And then e-papers from plastic substrates. You see the calendar. This is the calendar also. It's like a display. Then calendar also OLED display. No need to then replace the calendar. That automatically tomorrow is the next month. That display itself automatically changing by Wi-Fi signals. Nowadays we know very well about that Wi-Fi lighting system. So it automatically changing that complete display, complete calendar and the photographs, everything changing, and automatically it looks like any picture you can select it and then you can put it on your screen. So one day you want to put your photograph on the screen, then you can put it on the display. You want to replace some other photograph, then you can put it on the display of your calendar. That flexible display. And these are some of the displays people are using for biomedical applications. So you may heard it that so it's biomedical means so this is a medical watch. Then so medical watch is used to monitor your heartbeat, the BP level, so that everything is used to monitor by using this type of flexible watches of OLED displays. So real flexible displays are almost like this. It is like a pen. If it's like a pen, then you just scroll it up. Out means then you will get a display. Then automatically scroll it down inside. So that these are some of the flexible displays that companies prepared. So that you see here mobile flexible displays. So I used to put this PPT in 2009 and 10. I prepared, used to put it flexible displays are possible in future. But how it is possible, we used to think, but nowadays it is possible. Samsung are having the flexible display mobile. So once you open that Samsung mobile, then entire screen you can use it. Once you put it, then automatically it is like an ordinary mobile phone. So flexible displays are possible in future. So flexible laptops are possible. Yes, of course. If all the things are used to fabricate on this surface, used to fabricate on plastic substrate, all the flexible laptop also possible. OLED, I told you that OLED lighting is going to play a very important role. You see here, so that DuPont is a chemical company. They announced to develop a generation 3 solution based OLED light material that can last a record lifetime of more than 1 million hours based on that their calculations. 1 million hours equal to over 100 years of constant use. So 1 million hours they prepared based on the calculations they put in on websites, few points so that 100 years of customers. So if light we are used to purchase a light and it is useful for 100 years, it's a very big achievement. So it is possible in the future but they never disclose that what type of material they have used for this material. This is a special material they used to synthesize and they used in for the application. And I told you that these are all the inkjet printer OLED display commercially available in the market. So LG with the DuPont OLED technology, these are all the inkjet printed OLED large display, large area display, flat panel, high definition displays. So I told you that inkjet printing, and I showed some of the PPTs for inkjet printing. The same inkjet printing they are used to prepare this type of a big of organic light emitting diode displays. It is commercialized. Nowadays you may get it in LG showrooms or even in smaller electronic showrooms. I told you that this is a transparent OLED. Nowadays, earlier we used to have a navigation separately in here. You see here that they are using the navigation in there on the shield glass. Shield glass is the front glass. Once you turn on it, automatically the LED started to glow. Once you turn on, then automatically then it is used like a transparent that glass. So wherever you can then fix your OLED system, OLED displays in very easy way. Very easy. And I told you some of the lighting applications of organic light emitting diodes. It is highly useful in the future. Definitely, I told you that definitely OLED light will change the entire lighting of our application, even our homes or anywhere in future. And then these are all some of the examples of flexible OLED, flexible mobile displays. That is the comparative. So LCD displays image, but OLED image. But this one is I told you, this one is I really put it for thin displays. That entire OLED thickness is maybe 1 to 3 micrometer because that micrometer thickness only that entire layer they used to do. But they used to shield it by glass. Glass are laminated by glass. That is the reason it looks like a little thicker. But our point of view is still it looks a very thin display. So that much thin displays you can prepare it by organic light emitting diodes. So that these are all the comparisons between OLED and LCD of resolution comparison. This looks very good. OLED resolution is always better than any other displays. So I just skip for this failure mechanism due to time. So some of the physics I used to talk in failure mechanism. So that this is the sum of the material. All looks like a small molecule material. Yeah, all small molecule material, but this is a special. This is a special type of material synthesized in an R&D of LG group. So that what happened, and they have fabricated these OLED displays. So all are, cathode is aluminum, anode is 94, alpha NPP. Alpha NPP is this material. So this is the emissive layer material. ALQ3 is a green emission material. This is another material. So that you see here that this is electron injection layer. Without electron injection layer, what happens? So that from aluminum charge carriers are injected into ALQ3, but the additional barrier is very high. So that's why the inputs we are used to this two layer. After injecting these two type of layer, what we have achieved that I will put it, all the layers are prepared by vacuum technique simultaneously. All 4 layers are prepared in a chamber because it is not dissolvable in solvents, so that evaporating it in a vacuum chamber. So simultaneously evaporated and then finally we prepared the entire device. So alpha NPP layer of 15 nanometer and then emissive layer of 15 nanometer. And then this electron injection layer we prepared in different nanometers like 1, 2, 3, 4, 5, 6, 7, 8 nanometer. This we know it very well. Nanometer is very difficult. Even 1, 2, 3, 4 nanometer is very difficult to control that layer. But finally, aluminum electrode of 100 nanometer. Thickness is you see that entire thickness is less than 500 nanometer only. So beautiful, then OLED is prepared. These are some of the properties we measured. I will skip all those things that we need to guide time consuming. And so you see the final fabricated device, 3 mm into 3 mm pixel for green OLED. I told you that the electron injection layer we have used between aluminum and the adhesive layer. These two electron injection layer, you see that this layer of thickness 3 nanometer, this layer of thickness 5 nanometer, without electron injection layer. I told you that turn on voltage is a voltage required to turn on the pixel. That once you reach the 10.2 volt peak, then only the pixel is started to turn on. 10.2 voltage is required to turn on the pixel. But after using this two layer of 3 nanometer, 5 nanometer thickness, you see the turn on voltage is reduced to 5 volt. So that it is what is the role of this two electron injection layer mean? It is efficiently injecting the electrons from electrode to the adhesive layer. So that is the reason it is used very good. Electron injection layers playing a very important role in LED. So that is the reason. You see that the luminescent efficiency is drastically increased from 400 to 6,000 catalog of biggest. So current voltage also reduced to 10 volt to 5 volt. This is a fabricated devices. So some of the recent updates in OLED displays. You know in clinical about the bifolding galaxy device. Like Samsung introduced this bifolding galaxy device, and also Samsung slidable displays also they introduced. All are perfected flexible OLED, and then foldable Samsung tablets, foldable Samsung tablet is there. This is the OLED displays with the quantum dot. They mix the quantum dot in OLED displays, and they fabricated a device with the high resolution displays. So this is the real Samsung 2D quantum dot OLED displays. This is the highest the resolution displays in the world. You see here Samsung 2D in quantum dot organic light OLED displays. 99.8% of this is like a resolution point. We used to say PCI E3 gamut is the resolution mentioned. Just to mention the resolution. Highest resolution displays in the world is 2D quantum dot embedded organic light emitting diodes fabricated by these guys. It is available in market. You can get it when you go to the market. You will get it this display, but price is little. So that is the reason. So that these are the reason updates in OLED. That you see the LG flexible road printed. This is a road printed large area display. Road printing. I have shown one slide that road like a paper printing. So this display, this television is printed like this. So if you are printing, if you are preparing a displays like a paper, how many displays you can prepare it in one day? Large number of displays. So once the production is very easy, what about the price of the display? Production is easy, price also easy. So I will produce this one in 10 rupees mean I will sell it at least 15 or 20 or double the time 20. The production cost of the display is 10,000 rupees mean I will sell it maybe 20,000 or 25,000 rupees. So that production by roll printing you can prepare a large area displays with simple production technique. So that is the reason in future that this type of television going to play a very important role. Definitely, I am sure you will get your home like this screen display. You that this much of very big size television you will get it. But the important point is you will not have such a big home or hall in your house. So that much production. So that much cheap cost displays are available in future because of the ease of fabrication and the availability of huge amount of material. So people are working over here. This is a flexible. It looks like a table, but it is not a table. Once you switch on this table, automatically you see the display is thrown out. The display is thrown out, and then you will see the television. Once you don't want to see the television switch off, this automatically this will pull it down. So then what happens? It is just like a table. This is like after the display. It is prepared by the remote printing. So this is a reason for Japan is not reasonable. The 10 years before itself they have prepared this display. the display, you see that they are standing here, but display looks like a bigger one. So that 155-inch sized organic light diode displays. So small size OLED parts they connected together and forming a bigger display like this much bigger screen. OLED television, they have prepared by the HPC electrical displays. Not now, that 10 years before they prepared it. So I told you that organic lighting diodes so we are going to play a very important role in the future, not only in mobile applications, television applications, even in future it is going to replace all the lighting systems what we are having now. So because of the very less voltage is required to turn on the light means entire hall is illuminated by very less power, it can definitely be used to use OLED, and also lifetime is also very important. So at least you can use it at least 10 years without failure of any lighting system. So that is why very not only display size, they are also concentrating on the lighting applications. So small part only, but every day they are doing a lot of research and developments in a display point of view. They are able to achieve a greater height every day. That organic lighting diodes. I will stop because I will skip some of the important PPTs due to time. If you have any doubts or clarification, please.
It was very nice presentation. You started very well with the fundamentals, and I'm sure that the students in next slide, maybe in future they may have idea of getting into research of violins. And you said now the forum is open for business. Any questions from the students?
Sir, very nice, excellent presentation. My question there is a how long is organic material existent? The disposable of organic material, OLED, that is material. What is is there any hazardous to the nature? If it is a bulk material, definitely it will affect the nature. What is the solution? Any research, we have to give the find out the solution. That is a thing. Since organic material, how far?
Comparing to you know much better than me because you are chemist. So organic material, all the materials are organic materials. Some materials are chemicals are hazardous. But not that much hazardous to the nature. But it is the biodegradable. We know it very well. So carbon, hydrogen, biodegradable, biodegradable, inorganic matter. That's why all peoples are looking for the anyways, and the ease of fabrication. Ease of fabrication, in organic materials, it's very, you know it very well that people used to synthesize lakhs of molecules every year. So that they used to cut it and then they used to add then you form new molecules for different applications. Organic chemistry used to publish a lot of papers every year. So that available of large amount of material, also it is a biodegradable. So that's why it is not hazardous to the environment. One important point is that the organic material used in this space, all the space not stably in ordinary atmosphere. So that what happens, it is sensitive to the air atmosphere. Once it absorbs the oxygen, once it absorbs the air molecules, water molecules in the air, then automatically it's degraded. So that's why some of the materials they used to fabricate in a high vacuum condition, immediately they used to insulate it. Insulate means laminate. Laminate the entire device. Lamination means like a certificate lamination. They used to once laminate and then take a lead, currently in outside, then automatically it is good for long time. So not hazardous, but inorganic point of view is not it's highly useful to people. And also production also in people used to do it in humans. That's the reason it's definitely going to revolutionize in future. I mean, even not only in television point of view, lighting point of view also they are going to have a very great future lighting system on these days.
So, actually, the carbon dust,
Yes.
it has different luminescence property. Like if you work with some nitrogen as sulfur, we can tune the properties of the luminescence. Is it possible to use this as a co-LED material? Carbon dust.
Yes, the people are embedded quantum dots. QD, yeah, quantum dots. Quantum dots, they embedded with OLED, they achieved by a sensor. Achieving. They are embedding with OLEDs, they are used to get resolution point of view also. And the efficiency also they are using it.
Thank you.
What is the minimum fluorescent emission required to act
Yes.
in terms of net power?
It is a very good question. Minimum fluorescence emission is we are choosing our material based on the luminescent part of only we are taking the luminescent layer. Using layer, what is the role of using layer? That layer, not such rules we find together, emission is safe. So that luminescent material only we are using. Here ALQ3 is a very good green emission material. That's why we use it for green emission based OLED. And the OLED is only in green emission, not all emission. So that they used to combine together the forming. Even white OLED, they are combining 3 layers. Red layer, blue, so that all 3 layers they combine together forming a white emission. So creating a white emission.
In the absence of more questions, I take opportunity to thank Dr. Sethuraman and I, on my own self, and on behalf of Department of Chemistry and Organizing Committee, I thank Dr. Sethuraman for a very wonderful lecture. Thank you, sir.
Now I request Dr. S. Raghavan, the convener of the conference, to honor Professor with a song and a moment.
Thank you. Thank you.
Now the next session is actually water presentations. Those who actually already the schedule is given. Those who are presenting at this hall, this stage here. Those who are presenting at Jnanatharam hall, please move to the. So volunteers will assist you to.